Ladies and gentlemen, a very good morning to all of you. Thank you all for waiting. After weeks of university level competitions across Malaysia, we have all gathered here today for the next phase of the National Materials Lecture Competition 2024, which is the semifinals. Today, we will get to watch the best presenters in Malaysia all on one platform, and it's definitely something you don't want to miss. We will now be starting off with the Malaysian national anthem, Negaraku. Assalamu alaikum and a warm welcome to everyone once again. Thank you for joining us today at the National Materials Lecture Competition 2024. I'm Isha and I am your Master of Ceremony for this exciting event. It is with great pleasure that we from welcome you to this prestigious MLC 2024 semifinals. To start off, I would like to brief you all about the competition guidelines. For starters, we have guidelines on attendance, which is in just a moment. The guidelines on attendance states that the National MLC 2024 will be conducted in a live session. All competitors are requested to attend and deliver their presentation through Zoom, and the link has been provided by the host via email previously. The program schedule states that the competitors can refer to the tentative program for the presentation schedule. Please be present at all times during the competition to avoid any delay of the event. Competitors are responsible for controlling their own presentation slides. However, in case of any technical difficulties, the host's technical team will be available to assist in sharing the slides. Regarding presentation time, each competitor must deliver a 15-minute presentation in English on a topic related to materials or mineral science and engineering, followed by a 5-minute Q&A session with the esteemed panel of judges. Presentation ethics involves competitors who are expected to dress in a formal attire and have their video cameras turned on during their presentation. Cameras may be turned off when the competitor is not presenting. Thank you all for your attention. Now, we're honored to have distinguished guests, juries, and participants from various institutions with us here today. It is my pleasure to invite the organizing chairperson of National MLC 2024, Dr. Muhammad Kari Faiz, to deliver the welcoming speech. Afterwards, I also kindly invite all of our Muslim attendees to join him in a moment of reflection as he conducts a dua recitation.
Yes, the audience members. My great honor and pleasure to welcome you all to the practice lecture of the national level of the we get on to celebrate incredible talents and passion of young graduates and engineers. But also to select the best among them to proudly represent Malaysia on the international stage. This challenges us is a testament of hard work, innovation, and dedication of each participant and the participating leaders. I would like to take this opportunity to express my interest to the entire planning committee. For hard work, commitment, and tireless efforts have been instrumental in making this event a success. The thanks also goes to the Faculty of Engineering, the University of Malaya, for their unwavering support, and to IFM for generous sponsorship, which has made this event possible. All the participants, I wish you the best of luck. May your presentations reflect the depth of your knowledge, creativity, and vision. Remember, this is not just about winning, but about learning and sharing your insights with others. May the best participant win, and let us all enjoy this remarkable event together. Now, I would like to recite a dua so the Muslims can join me for the dua presentation. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. In the name of Allah, the most gracious and the most merciful. O Allah, we begin this gathering by seeking your blessings. Grant us as soon as successful program today, that the participants to deliver their best with clarity, wisdom, and confidence. O Allah, with the all-knowing, the omniscient, and the open and judge. So for the judges, we stand in fairness so that their judgment are sound and just. We ask you to bless all those involved with your mercy and success. O Allah, grant all participants strength to excel in the spirit of sportsmanship, its competition, its source of learning and growth for all. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. صلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Thank you, Dr. Karifais, for the inspiring words. Next, we have the chairperson of the Materials Lecture Competition Committee from the Institute of Materials Malaysia, IMM, Dr. Abdul Hakim bin Muhammad Yusuf, to give his special remarks.
Thank you very much to the MC, Ms. Isha. Assalamualaikum and a very good morning to everyone. Ladies and gentlemen, esteemed participants, and distinguished guests, a warm and heartfelt welcome to the semi-final of the National Materials Lecture Competition 2024, IMM MLC 2024. Today marks a special occasion as we gather to witness and celebrate the extraordinary talent and passion that each participant brings to these competitions. Your dedication and commitment to excellence have brought you here, and we commend you for taking up this exciting challenge. It gives me a great pleasure to greet and welcome all guests, judges, and participants to the semi-final of the National Material Lecture Competition 2024. This is the 30th edition of the National MLC, organized by the Center of Advanced Materials, Faculty of Engineering, University Malaya. The MLC started in 2012 as an initiative by MMM to create a platform for young students and researchers, particularly in the field of material science and engineering, to showcase their presentation skill and share their knowledge on the issue related to materials and their role in society with diverse audience. After a thorough screening process, 13 participants from Malaysian universities were selected to compete in the semi-final round. The top 5 presenters will advance to the final stage. The champion of the National MLC 2024 will represent Malaysia at the Young Persons World Lecture Competitions, or so-called YPWLC 2024, which will be held virtually in the UK. It is worth noting that Malaysia achieved second place in last year's International YPWLC through our representative, Ms. Kugambikai. It was a great honor for us to win such a prestigious award on the international stage last year. Hopefully, we will be the champion at this year's YPWLC. This event would not be possible without the unwavering support of our sponsors, volunteers, and the organizing committee, who have worked tirelessly to ensure a seamless experience for all involved. I want to extend my gratitude to the National MSc 2024 Organizing Committee from the Center of Advanced Materials, Faculty of Engineering, University of Malaya, for their steadfast commitment in organizing and promoting this year's MLC over the past few months. This hard work has been instrumental in making this event a success. We would also like to extend a special welcome and a big thank you to our 4 competition judges for their contributions to this event, namely Associate Professor IRTS Dr. Wan Sharuzi bin Wan Harun from University Malaysia Pahang Al Sultan Abdullah, UMPSA, Associate Professor Dr. Sarizam bin Mamat from University Malaysia Kelantan, IR Hanafi Ali from Sarawak Energy Berhad, and Dr. Muhammad Firdaus Suhur from Petronas Research Center Berhad. Without further ado, let the competition begin. We wish you all the best, and may this day be filled with remarkable achievements, innovative ideas, unforgettable moments, and the joy of embracing your passion. Let's make this semi-final of the National MNC 2024 a resounding success together. Thank you very much.
Thank you, Dr. Abdul Hakim, for the wonderful insights for our audience. As we approach our event today, it is my honor to now introduce our esteemed panel of juries who will be evaluating today's presentations. Let's begin by giving a brief introduction of their backgrounds. To start off, we have with us Associate Professor T.S. Insigne Dr. Wan Sharuzi bin Wan Harun, who is currently an Associate Professor in the Department of Mechanical Engineering, College of Engineering, UMPSA. He is globally recognized as an expert in power metallurgy, material technology, and additive manufacturing processes. He is also the founder of Green Research for Advanced Materials Laboratory, GRAMS Lab in UMPSA. Next, we have Engineer Hanafi Ali, who is a professional engineer with the Board of Engineers, Malaysia, and also a professional member of IMM. He is an expert in integrity assessment, contract administration, and static equipment management. He is currently overseeing the materials, corrosion, and inspection discipline at Sarawak Energy Berhad. Next, we have Associate Professor Dr. Sarizam bin Mamat. He is an expert in welding metallurgy and arc physics, mainly focused on the microstructure, transformation behavior, and mechanical integrity at Weldment's heat-affected zone HAZ. Appointed as international collaborator in Joining and Welding Research Institute, Osaka University, Japan. He is also the current dean in Faculty of Bioengineering and Technology, University Malaysia, Kelantan. Finally, we have Dr. Muhammad Firdaus Suhor. He holds a Doctor of Philosophy in Chemical Engineering from Ohio University, USA. He has 21 years of experience in the field of corrosion and developed specialized skill set in addressing materials and corrosion-related challenges within oil and gas industry. He is also currently serving as staff researcher at Petronas Research, Sendirian Berhad. Now, I would kindly ask the judges and the organizing chairperson and the chairperson of IMM to turn on their microphone so we can take a group photo. Turn on your cameras. Once again, I would request our judges to turn on their cameras so we can all take a group photo virtually. All right, on the count of 3. 1, 2, 3. Okay, one more. Count of 3. 1, 2, 3. All right. Thank you very much. Now I will introduce our presenters for today. Each of them has put in tremendous effort and dedication to prepare for this competition. We have with us from Curtin University, Clara Ida Norman, from TAR UMT, Ong Karkian, from Taylor's Ang Wei Xiang, from UKM, Ahmed Firdaus bin Amran, from Jerome Liu, from UMS, Normaiza binti Nordin, from Unicel, Yogasri Chandran, from Uniten, Kumudasri Utaya Rajan, from UPM, Sarveshini Yogendran, from UTEM, Aslam Hadi bin Hamza, from UTHM, Natasha Salsabila, from UTM, Aina Amira binti Marzuki, and from UTP, Siti Shaliza Kasida binti Saleh. Let's all wish them best of luck for the competition today. Now, before we begin the presentations, we will take a moment for a group photo with all the participants and the audience. Once again, I would ask everyone to kindly turn on your cameras so we can take a bigger group photo. All right, 1, 2, 3. All right, 1, 2, 3. All right, thank you very much for your patience. Now, we will start with the next phase of our event, which is our first presentation. Please welcome Ong Karkian from Tunku Abdul Rahman University of Management and Technology. He is a master's student and he will be presenting on ionic liquid as promising material to optimize the EDLC performance. The stage is yours now, Ong Karkian.
Okay, a very good morning to everyone. I'm Ong Kakian from Tunku Abdul Rahman University of Management and Technology. And today I'm here to present my topic, which I only liquid as promising material to optimize the EDLC performance. So why we need to have a renewable energy? I think everyone knows that the conventional way of generate the energy will be burning the fossil fuels. However, burning a fossil fuel actually brings a lot of drawbacks, such as a climate change, because burning of fossil fuel actually will emit the greenhouse gases and cause a greenhouse effects. That's why we like to stop the lesser the emission of the CO2. So and also uh, the fossil fuel actually is a non-renewable energy. They will going to deplete soon if we keep using it. That's why there is a need to have a presence of renewable energy. So in order to, we need to find somewhere to store the renewable energy. That's why there's a presence of the electrochemical devices. We would like to store the renewable energy. So we have battery, we have fuel cell, and supercapacitor. So let's compare these three types of the electrochemical devices. So as you can see from this graph, actually we are comparing capacitor, supercapacitor, battery, and also fuel cell. So this is a graph that specific power against a specific energy. So for the first one, which is the conventional capacitors, so there has a high power density, and they have short charging time, long cycle life, and low energy density. But for the battery shown in green, it has a high energy density and long charging time, and it also has a low power density and short cycle life. However, our topic today is supercapacitor. It has a it's a high power density, short charging time, and also long cycle life, and it has a moderate energy density. By just comparing the capacitor and battery, and with the supercapacitor, actually supercapacitor is a better option compared to the capacitor and battery, because it has a long cycle life, short charging time, and also moderate energy density that do not that that combine the advantage of capacitor and batteries. So there are a few types of supercapacitor that I will introduce later on. So what is supercapacitor actually? It's an electrochemical device that store high energy in electrical form, which is capacitance. So they're having different type of working mechanism. So we have the first one, electric double layer capacitor, which is EDLC. They are undergoes a non-Faraday reaction, which the charge transfer do not involve any redox reaction. So the ion absorption and desorption at the boundary of the electron and electrolyte actually is by electrostatic force. So it is reversible. For the pseudocapacitor involving the Faraday reaction, so the charge transfer is involve redox reaction. So for the hybrid supercapacitor, we are combining the EDLC and pseudocapacitor, means we have Faraday reaction and non-Faraday reaction in one devices. But for my topic today, I will be more focused on the EDLC. Why is it so? So before that, let me explain again how is it works. So as mentioned, as shown here, so initially the electrolyte, the ions, anion, and the current actually is in free moving state. So once we apply the current, or we call charging, so once we charging, and the the ions will move to the respective counter electrode. So the cation will move to negative terminal, and the anion will go to the positive terminal. So once we want to use the energy, so it's called discharge, and they will go back to the original state, and it is reversible, as I mentioned just now, because they are just rely on the absorption and desorption by electrostatic force. That's why, because of this reversible nature, they are actually they have a high cyclability. It means they can use many times, the cycle life is longer, and they also have a high power density, high charge and discharge rate. That's why we are using EDLC today. So in the EDLC setup, we have electrolyte and electrode. So let me explain about the electrolyte. We have different types of electrolyte. So the conventional way one will be the liquid electrolyte. Liquid electrolyte is the most the firstly developed type of electrolyte. So they are actually quite widely used until today. So they have their own advantage, such as they have a high ionic conductivity and they're quite ease of fabrication, and that has a very low cost to make it. But it has its own advantages, such as leakage risk, because the battery might leak out as shown here, and it has a corrosion issue. That's why they have a limited safety, because they are always using the organic type of chemicals, and quite flammable when we apply at a high temperature. So that's why they also might cause environmental impact once they leak out. So in order to replace the liquid electrolyte, the researchers start to develop polymer electrolyte. So what is polymer electrolyte? Polymer electrolyte are just consist of polymer and salt system. So polymer will be as a host polymer in the electrolyte, is a main component. So why we choose polymer is because they are light in weight, they are quite safe and flexible. So for the salt, so this salt is consists of cation and anion. They can act as a charge carrier. So they are moving along the polymer chain. So we have a lot of type of salt. We have lithium salt, sodium salt, and magnesium salt. So also we can have different type of conductor based on the salt using. So for polymer electrolyte, we have few types also. We have the solid type, composite type, and the gel type. So for the first one, solid polymer electrolyte. So it is still a polymer salt system, but in the solid state as shown there. So solid state is to replace the liquid electrolyte. So that's why they will not leak out. They will not leak out because in solid form, and it has a better safety properties compared with the liquid electrolyte. However, they have their own drawbacks, disadvantage. The first one will be low ionic conductivity. So because they are in solid state, they actually, the ion inside the polymer electrolyte chain is quite difficult to move. So when very hard to move, they could not conduct so efficiently. So another one will be low interfacial contact. So low interfacial contact means the contact of the solid polymer electrolyte and the electrode, both sides. So since they are solid, they have a low wettability, means they didn't have a good contact with the electrode. So the ion diffusivity across the electrode also quite poor. That's why the resulting EDLC or other electrochemical device also would not be so good performance. So that's why they have a very limited application on electrochemical devices. For another one is a composite polymer electrolyte. So composite polymer electrolyte actually is quite similar with the solid polymer electrolyte, but they are just add on some filler. Filler such as the normal one will be the silicon dioxide and titanium dioxide. So the purpose of adding filler is to decrease the degree of crystallinity of the polymer. So because the polymer initially is quite is crystalline, and when we add the filler to disturb the orderness of the polymer chain, so they could have more free volume, allow the ion to move. So we expecting a better ionic conductivity in the composite polymer electrolyte. However, the additional of the filler is not so effective in improving the ionic conductivity significantly, because the filler inside the polymer electrolyte might cause, when we put excess in filler, it might block the ion transportation pathway. So that's why it has it does not very have a good significant effect on the composite polymer electrolyte. So for another one is a gel polymer is quite popular nowadays. So how to prepare the gel polymer will be, we entrap the solvent in the polymer host and forming the three-dimensional network. So they are integrating the characteristic of solid polymer and liquid electrolyte. So there is a liquid and with what we call as semi-solid. So the advantage of gel polymer will be they are flexible, shape tunable, which is shape tunable. Whatever shape that I want, I also can fabricate. So there also no leakage because the solvent is being entrapped inside the polymer network. And another one that exhibit the high ionic conductivity compared with the solid polymer electrolyte and the composite polymer electrolyte, because the ion are able to move within the 3D network. So quite freely moving. And another one is good interfacial contact. So comparing with the SPE, solid polymetallic, gel type will be, because there are some wettability, they're able to have a good contact with the electrode. So the diffusion, ion diffusion will be also be better. So the performance, the electrochemical performance also will be better. So just now I have mentioned that we are entering different types of solvent. So different type of solvent also give different type of gel polymetallic. So we have the first one is organogel. We are using the organic solvent such as the plasticizer mainly to soften the polymer chain. We have the example diethyl carbonate, propyl carbonate. However, the organic solvent, as I mentioned just now, similarly to the liquid electrolyte, there are corrosive solvent. They are quite flammable. So they also have a low mechanical properties. And to replace the organic solvent, we have used water as solvent, so-called hydrogel. So however, using a water also got another drawback because they have a low operating temperature, which means that when we apply hydrogel in a high temperature, because water might start to evaporate and it might affect the performance of the hydrogel polymer electrolyte. That's why we come out with another type, which is ionogel. Is by using ionic liquid, we trap the ionic liquid inside the gel polymer electrolyte, so-called ionogel. We are using ionic liquid. And the resulting ionogel will have a higher thermal stability compared with the other type of polymer electrolyte, and they have a high ion content, means they have a very good conductivity, ionic conductivity compared with the rest. So actually, what is this ionic liquid? So this ionic liquid is, they have a high ion content in the solution. So they consist of a lot of cation and anion. So it's to increase the concentration or the number of charge carrier to increase the ionic conductivity. So another one will be high thermal stability up to 400 degrees Celsius. So they are able to replace the organic solvent. And another one will be low vapor pressure. So since they are low vapor pressure, they are non-volatile. They are not easily to vaporize and leak out the electrolyte. So this slide shows the factors governing the ionic conductivity, also equal to NQ mu, where N is the number of charge carrier, Q is the ionic charge, and mu is the ionic mobility. So we are planning to add ionic liquid in the gel polymer electrolyte as an ionogel. So when we have ionic liquid, it will increase the number because there is a lot of ion content, and increase the number of charge carrier, and the resulting ionic conductivity also will be as it a better and a higher result compared with the rest. That's why we are using ionic liquid in this project. So how to prepare ionogel polymer electrolyte will be, we are using different weight ratio of the polymer and salt. We varying it and we find the best ratio, and also the ionic liquid we stir overnight until homogeneous, and we do solution casting on it, and we dry in the oven until a dry texture, and this is how it looks like. So for the characterization part, we are doing quite a lot of characterization in order to find out what is the best ratio of the polymer, salt, and ionic liquid to form an ionogel. So the first one, we have electrochemical impedance spectroscopy, EIS. We have differential scanning calorimetry. We also have thermogrammetry analysis, LSV, rheology, and transfer number. But the most important one, the most significant one that we would like to decide which ratio is the best will be the electrochemical impedance spectroscopy to check on what is the ionic conductivity. The highest ionic conductivity will be chosen to fabricate an EDLC cell when we would like to evaluate their performance. So in order to fabricate EDLC cell, we need to have carbon-based electrode, two piece. So we have a lot of carbon sources, such as carbon black, multi-wall carbon nanotube, and also activated carbon. And we bind it together by using PVDF, and we dissolve it in the solvent and then P-solvent. And this is how it looks like when we coat on the coin cell CR2025. So this is how we fabricate EDLC cell. So both sides, and we have the positive case and negative case, we have carbon-based electron. And in between, we have the most conductive ionogel polymer electrolyte, and we store it, close it in the CR2025 coin cell, and we will run some electrochemical performance evaluation, such as we have cyclic photometry to check on the specific capacitance, electrochemical behavior, and we also have another type of electrochemical impedance spectroscopy in low frequency to check any charge transfer resistance and bulk resistance. In order to have a better EDLC, we must opt for low bulk resistance to have a better specific capacitance. So another one will be galvanostatic charge discharge performance. These tests are mainly to test the cyclability of the EDLC cell. So we also can know what is the specific capacitance, power density, energy density, and also complete efficiency of the EDLC cell. So conclusion, when we are using ionic liquid, which is a high ion content, and it can act as the ionic conductivity booster. And when we have high ionic conductivity, it also will increase the specific capacitance on the EDLC cell. And also ionic liquid is high thermal stability and low vapor pressure. So that would the resulting anode gel or the EDLC also will show improved safety, better stability, because they are not easy to leak out. They are not flammable. So it's quite safety. So, and I think that's all for me. Thank you.
Thank you, Mr. Karkin.
Yes.
Can hear me, right?
Yeah.
Very nice presentation, full of information. Okay. So now actually I'm one of the judges here. So we have 4 judges here. So I would like to invite my colleague. Maybe we start with IR Hanafi. Do you have any question to ask? I think you mute your mic. We can't hear your voice, Mr. Hanafi.
I would like to ask one simple question.
Yes.
To Mr. Ong. What is the any applicability to how do you commercialize this? Is it possible to commercialize this?
Yes, of course. So, but before the commercialization of this EDLC or by using this iron gel, we must reach certain criteria on the electrochemical performance, such as we need to run the stability, or I mean the cyclability of the cell up to 10K cycles. Like if the 10K cycle also show a quite stable, so only we can commercialize. And also the specific capacitance, and the specific capacitance is how much they can store the energy, and also the power density, how fast they can deliver, also a quite important criteria in order to commercialize. But I think there's some further work need to be done.
All right, thank you.
Okay. So next judge, maybe Dr. Sharizam. Do you have any question to ask?
Okay, thank you, Doctor. Mr. Ong, thank you very much for your presentation. Yes. Could you please show me the slide number 15? I think slide number 15. Just a very simple question, actually.
Yeah.
The preparation of IGPE. Then I'm not sure whether is there any the exact setting temperature for the drying during the preparation.
Okay, from the drying, we are using 60 degrees Celsius for overnight. So we will leave it. We will set a certain maybe 16 hour in 60 degree of oven. Then we will get this kind of gel type of polymer electrolyte.
And the temperature will be the temperature must be set properly, or just let it,
or is quite flexible, but when I do, I try not to have a very big range. For me, plus minus 5 degree is okay with that.
Okay, thank you.
Thank you, Prof. Next, Josh, Dr. Firdaus. Do you have question to ask?
Hi. Just on the last slide, regarding the performance of your batteries here, can you elaborate more on the thermal stability? Because most batteries age is limited by the thermal stability throughout the life. So can you elaborate more on that?
Okay, so for the thermal stability, we are running the TGA for every ionogel electrolyte. So for the ionic liquid itself, it has a degradation temperature around 400 degrees Celsius. So when we add inside the ionogel, when we prepare the ionogel electrolyte, it shows around 370 something of I do not have the exact value, but so far what I can remember is around 350 and 370 of the degradation temperature. So I believe around 305 or 370 is sufficient for the thermal stability of the ionogel electrolyte.
Okay, thank you, Dr. Firdaus. Do you have any more question to ask, Dr. Firdaus?
No. Thank you.
Okay, thank you, Ong. Okay, Ong, maybe one question from me.
Okay.
Yeah, as I said, actually many information that you present today is quite new to me. Okay, then I'd like to know about the long-term stability, okay, of your research on the EDLC under different environment condition. Can you comment on this?
Okay, under different type of environment, we might for the stress test, we are doing the different type of maybe voltage and also high temperature to monitor we could do that. We could do different type of voltage, high voltage, and also high temperature to monitor the EDLC. But I need to be honest to you is so far we haven't reached that stage yet. So we are still monitoring the cyclability under the normal usage, the normal condition.
Okay.
Yeah.
Thank you, Ong. It's very clear answer.
Thank you all the judges.
Okay, thank you so much. So I pass to Secretariat. How should we invite next presenter or what? Thank you.
Thank you, Ong Karkian. Next, we have Siti Shaliza Kasida Binti Saleh from University Technology Petronas. She is a bachelor student, and her topic will be on advancing durability, self-healing coatings.
Thank you, Ms. Lee. Can you hear my voice?
Yes, I can hear you, and good luck.
I need to share my screen, but someone is... Okay, thank you. Let me share my screen first. Okay, Assalamualaikum and a very good morning to the honorable judges, MLC 2024 Organizing Committee, and members on the floors. Before I introduce you the topics of my presentation today, let's start with a little imagination. I believe nowadays everyone have smartphone, and imagine the screen of your phone cracks or by a sharp object. Instead of rushing to get it fixed, it heals by itself. How cool would that be? This might sound like science fiction, but today we are going to explore the world of self-healing material and how this concept is becoming a reality in various applications. Now, What if the material around us could do the same thing? Let me narrow it down to the self-healing coatings. I am Siti Shaliza representing UTP. Today I'm going to talk about how these special coatings are making things last longer. So the title of my presentation is Advancing Durability Self-Healing Coatings. To give you a real world example, let's look at a product that already using this concept. This video showcases a screen protector that can heal itself from scratches. It is actually one of the great example of how self-healing material are starting to make their way into everyday items, showing just how practical and innovative this technology can be. Here, we can visually see that the one with self-healing protector don't have any scratches as compared to the one that doesn't have any self-healing protector. Looks interesting, right? Well, now we have seen how the self-healing materials can work in smartphone. Let's take a deeper look at what makes this coating so unique. You might be wondering what exactly makes a coating smart. Well, smart coating are special because they can respond to their surrounding in a way that traditional material cannot. There are a few types of smart coating, but in this presentation, I will be focused on self-healing coatings. This self-healing coating actually designed to exchange to have the stimuli responsive behavior where they are able to change their properties in response to the external stimuli like pH, temperature, or even the mechanical damage. This video explains how coatings change their behavior when exposed to the mechanical damage. This behavior is the one that making them incredibly useful in any application. Can see the restructure of this material that have the self-healing coating. Now, let's highlight the critical needs for self-healing coatings. The primary challenge we face with conventional coating is their declining performance and durability over time. Conventional coatings, for example, in this case, epoxy coatings, are degrade over time due to physical factors like wear and tear, environmental factors like wind, water, or abrasion that can cause peeling, corrosion, or eroded. Thermal cycling also can lead to the crack of this epoxy coating that allow corrosive agents to penetrate and reduce the durability. So to address this problem and issue, the main objective of this study is to develop and characterize the self-healing coatings for improved performance and durability with broader goals and sustainable development. Have you ever wondered how the self-healing coating has the ability to heal? Or as I mentioned, they have the ability to stimulate responsive behavior. Well, it is actually because they contain healing agents that release upon damage. Let's focus on the most important part of these self-healing coatings, which are the tiny capsule of the microcapsule integrated inside this coating. These small capsule, they are filled with healing agents that they are stay still until the coating get damaged, such as when the scratch happen. This capsule coating can fix itself without any help. This means that the material stay protected longer and it reduces the need for repair and keep things in a better shape for a longer time as compared to the conventional coating as I mentioned previously. So this is actually the 4 main stages of healing process, which I will explain in details after this. And some of the example of agents are tang oil, boiling seed oil, and safflower. Now, let's talk about how we actually can create the self-healing coating using boiling seed oil. Please bear in mind, in my presentation, I will focus on using the boiling seed oil as a self-healing agent. For this part, this process starts for something as simple as flax plant, where the seeds are carefully dry under the sun and prepare them for the extraction of this boiling seed oil. Once these seeds are dry, it will undergo a process of cold pressing and boiling that allow the valuable linseed oil to be obtained. It is actually the critical components in the formulation of the coating. Moving on to the second part of the preparation of these self-filling coatings. This is actually one of the challenge and the critical part of preparing these self-filling coatings. So the extracted linseed oil is the one that get previously is treated by this urea formaldehyde particle, the purple color, and the yellow one is a droplet of boiled linseed oil. Actually, briefly, the process starts by creating emulsion to disperse the boiled linseed oil, and then we add the urea formaldehyde, and they will form a shell to encapsulate this boiled linseed oil by the process called polymerization. And of course, this microcapsule need to be combined with epoxy and hardener to produce the self-filling coating. So this image are the microcapsule of boiled linseed oil under scanning electron microscope. The spherical shapes is the microcapsule of boiled linseed oil. And then when we zoom in this part, we can see that these are the broken microcapsule. We can see that some boiled linseed oil are leached out from this shell. And this is the optical microscope image of microcapsule boiled linseed oil. Now, we have reached to the heart of my presentation on how self-healing mechanism actually work. This is where everything comes together. Imagine you have a surface with special coating. Over time, it might get scratched or damaged. But here is the magic. When scratch happens, the microcapsule within the coating breaks open, as you can see from this image. The healing agents of boiled linseed oil, in this case, they will release from these capsules and they will spread out and flow to the damaged area, to the scratch. And as this oil spread, it starts to react with the surrounding environment, which are the oxygen, which are the catalysts for the cross-linking process. So basically, the cross-linking process is creating a solid protective layer that seal this scratch. We can see that these are the heel side that protect the underneath material. So basically, to conclude this mechanism or the basic concept of the self-filling coatings, this process where the oil molecule are cross-linked, as shown in this video, the oil molecules, they bond together to form a strong solid polymer network that protect the material underneath. Now, to achieve the objective of this study, of course, we need to measure the performance of self-filling coatings. The self-filling coatings was applied on top of carbon steel plate. In this case, please bear in mind, to check the performance of self-filling coating, we apply the self-filling coating on top of carbon steel plate. So there are two tests conducted. The first one is for durability test, which are the scratch test, according to ASTM D1654, where the coated samples, they are subjected to control scratch. And then it is immersed in sodium chloride solution for 14 days. And this is actually the result. By comparing the traditional and self-filling coating, we can visibly see the formation of corrosion in traditional coating. And also, there are no healed region after 14 days of immersion. But in contrast, for self-filling coating, here we can see that there are minimal rusting because of the reaction between sodium chloride with the carbon steel beneath this coating. However, some of the scratch part are healed. It's proof that the self-healing coatings works and better as compared to the traditional or the conventional coating. So the second performance characterization is adhesion test. Well, adhesion test was conducted according to STM D4541, where the test conducted before and after immersion. From the bar chart here, we can see that the percentage reduction of traditional or conventional coating after immersion in sodium chloride are higher, which are 52.08%, as compared to the self-filling coating, which are only 38.95%. This means that the reduction of this, the less reduction of adhesion strength prove that the performance of self-filling coating after exposure to corrosive environment it is more effective as compared to the conventional coating. Based on these findings, it is proven that the self-healing coatings are better as compared to the traditional coating. Now, we understand how smart coating works. Let's quickly explore where this self-healing coating can be applied. Well, the versatility of this coating open up opportunity across many industry. For example, in this case, aerospace industry, oil and gas industry, specifically in pipeline application, automotive industry, the painting of your car, electronic devices, the one that I will share a video to you earlier, and of course, the construction and infrastructure. These examples highlight just a few of many potential applications of smart coating. Their ability to self-heal makes them invaluable across various industries. And looking ahead, it is important to consider the future market potential for this self-filling coating. There are several factors that will influence this market. First is the market demand. It is expected to grow significantly. Let's just directly look at this graph. This is basically, the graph is US self-filling coatings market. We can see a steady increase with compound annual growth, approximately 8 to 10%. And by 2030, it was expected the the market value is expected to reach between 12 to 15 billion, indicating strong potential for expansion. This growth reflects increased importance and application of self-healing coating across various industry. And of course, one of the important part is the sustainability. Sustainability is a key aspect of the development of self-healing coating, and it significantly contribute to these three pillars of sustainability, starting with environmental aspect. By using the renewable resource, which is the flux blend that I was mentioned in the methodology, it lead to the resource conservation, which align with the renewable approach. And next, economically, the self-healing capability of this coating, they support the circular economic by designing materials that can repair themselves and reduce the need for frequent replacement and repair that can lead to the cost saving over time. And finally, in terms of social sustainability, this coating contribute to the durability and hygiene of public spaces by ensuring longer lasting self-maintaining surface. With that, I have reached the end of my presentation. To conclude, self-healing coating is actually a game changer by using the tiny capsule filled with healing agent such as boiling seed oil. This coating can repair themselves when damaged, which means they can last much longer. And its performance are proven in the reduction of adhesion strength between conventional coating and self-healing coating. Additionally, as we look to the future of the adoption of self-healing coatings, it is actually the smart coating contribute significantly to the three pillars of sustainability, which I was presented previously. And as recommendation for future research, first is to optimize the formulation of self-healing coating, and also to optimize the formulation of self-healing coating, maybe to add another additive like corrosion inhibitor, and also to conduct long-term durability to see the performance of this self-healing coating. To end my presentation, I encourage you to think about how this technology can be applied in our daily life. It might be beneficial for us. Well, with that, I have done with my presentation. Thank you so much for your attention.
Thank you, Siti. Can you hear me?
Yes, Doctor.
Okay, great. Yeah, you was talking, your presentation was about self-healing coating, right? And I think one of your slide, you did actually show the trend of the demand on this self-healing coating. So I like to ask regarding to that part. It seems like the the technology or the self-healing coating is already in the market.
Yep.
It looks like okay. Then my question to you is what is the different, the one that you are working on with the one that in the market?
Okay. Thank you so much for the question. Okay, actually the difference between my the self-healing coating that I will present with the one that already available in the market is we use boiling seed oil. And in other industry that already use this coating, for example, let me give an example. One of the car in Malaysia that are recently used the self-healing painting, they use TPU uh, polymer as and also a ceramic coating. But this one, we are looking forward to the greener solution. That's actually the difference between my coating, boiling seed oil with self-healing coating with another company.
Okay,
I
thank you.
hope answer your question.
Yeah, you did answer well. Thank you.
Thank you.
Okay, I would like to invite my colleague judges, please.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Siti, for the presentation. Very nice. Self-healing coating.
Yep.
Siti, I just want to ask one question, one simple question actually, regarding to the what you said that there is a reaction between sodium chloride with carbon steel. One of your slide, and then could you please explain more regarding to the I think the previous
This one.
yeah, this one, yeah. Yeah, do you can you explain more regarding to the reaction between the sodium chloride and carbon steel, and then do you check the surface of the surface of the carbon steel between carbon steel and the carbon steel, and then what is the main I'm not sure, maybe you can see the microstructure or what. If you just explain regarding to
The first question was
sodium
the
chloride and carbon steel
reaction.
react. Yeah.
Okay. The reason why I choose sodium chloride, please bear in mind the percentage of sodium chloride is play important role also in carbon steel plate. Because the reason is because this carbon steel is the most used material in the industry because of course it's cheap, and the reaction occur is two. The first one is reduction and oxidation. In a simple way, we can explain it the reduction reaction, oxidation reaction. In once we have this sodium chloride, the corrosive environment inside this sodium chloride is Cl, which are the chloride ions. This chloride ion will react with the carbon steel, which is the Fe, the ion elements in the Fe, to form iron carbide, to not iron carbide, to form the rusting. Actually, there are two. In anode part, they are the electron loose, and at the cathode, they will receive the electron. So basically, the formation of this corrosion is actually the main reaction, which are the anodic and cathodic process. And basically, iron, first they react with the H2O. Since when we using this sodium chloride, we dissolve the sodium chloride like powder inside the diluted water, so it's contain H2O. Then this ion Fe will loses its electron and react with chloride to form rusting. I hope you clear and understand my explanation.
It's okay. It's okay. Okay, thank you.
Right. Can I ask a question?
Please.
Just a simple question. On this particular slide, we see the protection that is the self-healing coating that's giving the base metal, yeah. So I just like to know, how does this self-healing coating has what is the life of the protection compared to the traditional coating, if applicable to the real world? For example, if it's subjected to UV light, UV ray.
Okay. actually, this coating only tastes for the according to the CO2, which is the sodium chloride. The reaction, unfortunately, further research on the UV light need to be further research lah. And then actually this reduction, of course, because of the process here is basically because this traditional coating, they don't have any self-healing agents, right? So they don't have the capability to self-heal. The reason why this one is much the reduction is higher as compared to this one, because again, when we get back to this one, we can see how this image have corrosion. It doesn't have heal site or heal region. But when we look at this side, the heal region protect this material from direct degradation with this chloride ion.
So just one more, just so the applicability of this self-healing coating is for mechanical damage only, right?
Yep.
Okay.
Thank you, Doctor. IR Hanafi, do you have one?
No. Thank you.
Okay. So I think that's all, Siti. Thank you so much.
Thank you.
All right, thank you, Siti. Up next is Jerome Liu from University Malaya. He is a PhD student and his topic is on Maxine, the future of fast charging battery.
On a road trip, your friend drives to a petrol station to fill up his car. In 5 minutes, he had a full tank and could travel 6.
Jerome, I think you're muted.
My apologies. On the road trip, your friend drives to a petrol station to fill up his car. In 5 minutes, he had a full tank and could travel 600 kilometers. You own an electric vehicle. You drive to a charging station to charge your car. And after 1 hour, you're still waiting for your car to fully charge, and you can only travel half the distance of your friend. Ah, what a bummer. Hello and good day, ladies and gentlemen. I'm Jerome, and I wonder, what is your ideal electric car? I believe it should at least possess the conveniences of an internal combustion engine car, low downtime, and long travel distances. Sorry, the mic. However, an ideal EV should start from the ground up, beginning with an ideal battery. So, let us talk about Maxine and our journey to pursue the ideal fast charging battery. Maxine is a 2D nanomaterial, the same class as graphene, that is made with a top-down approach using its precursor called max phase. Max phase is a structure consisting of alternating layers of Mx and A, where the A is a group 13 or 14 element, usually aluminium or silicon, and the M, a transition metal, and X is a carbon or a nitrogen. Essentially, the Mx layer is a transition metal carbide or nitride layer. To make Maxine, we have to etch out the A layer out of this MAX structure. And once you've done that, you add the suffix "in" to MX. The word is spelled out as Maxine, MXENE, and that is how this material comes about. The scanning electron microscope here shows the morphology of a max phase, and we can observe a tightly packed, bulky crystalline structure. And after etching it, the A layer out of the max phase, we can see prominent interlayer spacings between each Maxine nanosheet. And this structure is what we call a coordinate-like structure, and it is very much sought after in these material. And you can probably tell that this material has an outstanding surface area to volume ratio, and the transition metal nature of the material gives it an outstanding electrical and mechanical properties. Furthermore, the synthesis of MXenes endows them with tunable and unique surface chemistry, which in turn gives MXenes with incredible processability. For instance, they have a very high hydrophilicity, so we can dissolve them in aqueous dispersion, forming colloidally stable solutions, and even in organic solvents. So, how do we make this wonder material called MXene? It all begins by etching the A layer out of the max phase, like we have just talked about. And there are a couple of approaches to synthesizing MXenes. And the first ever synthesized MXene is titanium carbide. This was done by two researchers in Drexel University in 2011. In the hope of fabricating electrodes for better lithium-ion batteries, they immersed titanium aluminum carbide max phase in pure hydrofluoric acid. The pure hydrofluoric acid etched and exfoliated the max phase, forming a black viscous substance that is subsequently washed and dried, forming MXenes we know today. However, hydrofluoric acid, as everyone knows, is one of the nastiest chemicals one can ever come across in a synthesis. So naturally, researchers try to avoid using pure hydrofluoric acid and research for alternatives. The first ever alternative was developed in 2014, 3 years later, and this is known as in situ HF etching. In situ HF is formed by mixing fluoride salts, for example, lithium fluoride and ammonium fluoride, with an acid, in this instance, hydrochloric acid. And these mixtures, they form hydrofluoric acid on site, in situ, at a much lower concentration. These methods, they're extremely easy and primitive, cheap to run, and are feasible at room temperature. These all sounds too good to be true until you realize that because of the lower hydrofluoric concentration, their etching efficiency suffers. And this is further exacerbated when you realize that the fluoride salts, some of them have poor dissolution in water, lowering the already poor etching efficiency. And ultimately, hydrofluoric acid is used in the synthesis. It is a byproduct of the synthesis. So it is less than ideal if you want a completely green and totally fluorine-free MXene. Fast forward 4 years. Hydrothermal assisted etching using a conventional oven was introduced to make titanium carbide and niobium carbide. This was performed using in situ HF. And 4 years later, in 2022, a microwave was first utilized to make titanium carbide using in situ HF. And this was a feat achieved in Sunway University, Malaysia. And these complete exfoliation in less than 20 hours, which shows that it is a great improvement compared to the first method, which takes about 24 to 30 hours. Because in an enclosed chamber, when the max phase and the etchant are enclosed, the pressure increases with the temperature. So this aids the dissolution of fluoride salt in aqueous dispersion, enhancing their etching efficiency, while enabling us to use alternative solvents like alkali etching, green solvent etching, fluorine-free etching. And this also speeds up the reaction and makes the exploration of other MXene configurations much more possible. And last year, deep eutectic solvent was first used to make titanium carbide MXene. DES is a mixture of solvents with a melting point lower than any individual element. They boast the benefit of being cheap, easy to run, biodegradable, and has low toxicity. The first pair of solvents used were urea and choline chloride, and they reached a melting point of as low as 12 degrees. Do you know what is 12? That was the number of days it took for a complete reaction and exfoliation. This is totally unacceptable when you can make it in less than 20 hours using other methods. So, to address this, our team has worked on a new method. We optimized a new method to make green MXenes by using DES. So we enclosed the pair of solvents and the max phase in the chamber and used a microwave, a conventional oven, to achieve this solvable thermal setup. And we achieved a complete exfoliation in 18 hours compared to 12 days, which is a big feat compared to, well, many, many more fold of duration it takes for the conventional made. Now, let us now revise the evolution of maxine synthesis, how it has evolved from when it was first discovered and to today. In 2011, pure hydrofluoric acid was used to make maxines, and these produced beautifully etched materials. And 3 years later, in situ HF was used, and the effect of exfoliation is less than stellar. You can see the layers are not as wide and open as the previous structures. And then hydrothermal assisted etching, followed by solvable thermal assisted etching, were both introduced. These methods are both faster than pure hydrofluoric etching, and most importantly, they are totally green as well. Even better, they produce maxines of higher quality because the etchants used are less harsh to the material. These maxines are higher quality, larger flakes, they have less defects, and these are all paramount parameters to a good electrochemical performance of maxines. Now, after deciding the best way to make maxines, we're going to incorporate it in silicon anodes and make it viable. First and foremost, why silicon? What are we trying to replace here? The diagram here shows the anatomy of a battery. You have an anode and a cathode sandwiching a separator and electrolyte. Commercial batteries uses graphite anodes, and that is what we're trying to replace here. The maximum capacity a graphite anode can have is 372 milliamp per gram. Having said that, the capacity of silicon can go up to almost 10 times that of graphite. So why are we not harvesting this potential out of silicon anodes? There's a good reason to why we not do that. And the reason lies in the formation of a solid electrolyte interface, this SCI layer. When an electrode comes into contact with an electrolyte, during cycling, charging, and discharging, they react with each other, forming an SCI layer. A stable SCI layer is crucial to maintain a stable voltage and to prevent further reactions between those two elements. The problem with silicon lies in its massive volumetric changes during charging and discharging. So when a silicon particle is charged, it expands in size up to 300%, forming a huge SCI layer. And when it is discharged, it shrinks and the layer formed is destroyed. Consequently, you've lost the protection you just formed between the electrode and electrolyte. And when it expands again, when it is charged again, it forms a new SCI layer that is subsequently destroyed. When you repeat this cycle many times, eventually you get a very thick and dysfunctional SCI layer that increases the internal resistance of the cell and causes intense performance degradation. What do these translate to in real life? You get a very swollen and a very hot battery, which we don't want. So we've designed an improved strategy to make silicon anodes with dual maxine protection. This construction consists of 2 assembly methods. The first one will be mechanically mixing silicon nanoparticles with maxines via an electrostatic assembly, forming a layer-by-layer structure. As you can see, the silicon nanoparticles are intercalated between those maxine nanosheets, and this also prevents those materials from aggregating with each other. This structure is then reacted with maxine colloidal solution, again in a hydrothermal setup, and freeze-dried to form a porous and 3-dimensional maxine matrix. The former structure confines silicon nanoparticles and buffers their volume expansion, protecting them from rupturing, whereas the latter reduces the migration path of lithium ions and it accelerates the diffusion of ions and electrons in and out of the electrodes, enhancing the charging rate a battery can take. So your battery will no longer be swollen after prematurely, and you also won't get a hot battery after a fast charging session. With the implementation of this technology, We believe the use of silicon anodes can reduce the cost of battery because with silicon anodes, we can use less material to achieve the same capacity as conventional batteries. And with the use of less material, battery packs will have lesser weight. This makes the electrification of commercial vehicles like trucks and lorries much more feasible. And thirdly, the use of large capacity silicon anodes increases the driving range of EVs up and beyond, up to 700, 800, or 900 kilometers, compared to the most advanced electric vehicles you have that provide you about 500 kilometers. And even that is being extremely optimistic. Lastly, Maxine enhances the charging rate a battery can take. So now you can charge your vehicle from 10 to 90% in under 8 minutes compared to the 30 minutes at most at a fast charging station at the Tesla supercharger you need for a most advanced EV. So the next time you go on a road trip with your friend, not only you can go as far as he can, you can also fill up your car, charge your car as quickly as he fills up his car. With Maxine, we believe a greener future can be brought about. Thank you.
Thank you, Mr. Jerome.
Thank you. Thank you.
Very energetic. Okay, so you was talking about magazine.
Yes.
Okay, which is on the topic of fast charging.
Yes.
Okay, that's great. Before I ask you a question, maybe I would like to give the floor to my friends, colleague. Any one of you like to ask question to Mr. Jerome?
Jerome, what's
Yes.
the additional cost this Maxine will add to the current battery technology?
So believe it will, when it comes to current battery technology, it can improve the cyclability of the cell. That is to say, now your battery can last for way longer cycles. Because modern batteries, the most advanced one, the ones you use in cars, lithium-ion batteries, they can last from about 1,000 to 1,500 cycles. But when you integrate Maxines into this material, it improves the charging rate a car can receive. So you can fast charge your car more frequently without having to suffer the repercussions of fast charging. So your battery will no longer get hot when you fast charge it. So it can last for many more cycles compared to what it conventionally could. So up to probably about 2,000 cycles. And yeah, so that's the impact Maxines can bring to modern batteries as well, not just in silicon anodes.
I mean, the production cost, how will it add to the production cost? Because the final cost will be passed down to the consumer, yeah?
Actually, Maxine, you don't have to add a lot, you know, to batteries to actually experience the performance you gain. Because it's not exactly an expensive material compared to graphene. Graphene is such an old material, and yet it is still so expensive. Maxine is 3 times cheaper than graphene. And with the amount of material we add to graphite anodes in like modern batteries, it only adds about 5 to 10% of the cost to the main material because the cost isn't a lot. And Maxine, as an additive, is very functional, very efficient, even at low amounts. So it wouldn't add much to the total cost of a battery.
All right, thank you.
Okay, thank you, Mr. Hanafi. Prof. Sharizam.
Okay, thank you. Thank you, Doctor. Jerome.
Yes.
Very much for your presentation and your research. Very, very good presentation, I think. Then I just want to ask regarding to the in case of in actual production, what is the effect of the size compared to your new proposed battery and the conventional battery? Is there an effect to the size?
Do you mean to the packaging size?
Yeah, packaging size. Yeah.
Actually, because we're using silicon, in our research, we're using silicon, we actually need less material, you know, to get. If you were to have a battery of the same capacity, you would need less material. So naturally, the size would also decrease. So if we are comparing batteries with same capacity but different materials, silicon batteries, I mean, the ones that we have, the ones that we are researching, would be significantly smaller than a conventional battery.
Smaller.
Yeah, it will be smaller, more compact, more energy dense than conventional batteries.
Okay, thank you.
Thank you, Prof. Okay, my question before maybe Dr. Firdaus. If okay, you was talking about Mr. Jerome. You was talking about one of your point was on deep eutectic solvent, right? So
Yeah.
how I would like to know how that solvent affect the electrochemical performance and the stability of fast charging battery compared to traditional one.
Okay, this is the thing with, thank you for the question. This is the thing with Maxine synthesis. When it comes to synthesizing Maxine, the etchant matters. It will, because the harshness of the etchant, hydrofluoric acid is an extremely harsh chemical. So when you make Maxines with hydrofluoric acid, it introduces a lot of pinholes and defects on the Maxine nanosheet. The images I've shown, they are in bulk structure. But when we examine it under transmission electron microscope, we see thin layers. So when you etch a Maxine, when you make Maxines with pure hydrofluoric acid, what you do, because it is a very harsh chemical, it introduces lots of pinholes and defects on the structure. And this will disrupt the electronic conductivity of the cell of Maxines, which we don't want in a battery. We want as much conductivity as we can have. And with deep eutectic solvent, it will improve the performance because, one, it is a very mild etchant. It is a very mild etchant, not very harsh. And more importantly, because it doesn't have water in it, it is aqueous-free. It is totally organic. So when you make Maxines in this solvent, you avoid any complication of oxidation. So there are less defects, less pinholes on those Maxine sheets, on those level. So consequently, you have incredible electronic conductivity because there are no defects. There are very little defects, very little pinholes because of the use of organic solvent, completely water-free, because some of the radicals that forms in aqueous dispersion actually reacts with Maxine, and this is what happens in other methods, in pure hydrofluoric acid etching method. That is how DES will actually improve the stability, the oxidation stability of Maxines, their electronic conductivity, and even their life cycle. Thank you.
Thank you, Mr. Jerome. Dr. Firdaus, do you have one?
Yes, thank you, Jerome. Interesting presentations.
Thank you.
Regarding the battery applications later in the industry, I
Mm.
think the most important is on the thermal stability because
Yes.
the consumer has experienced a lot of fire breakouts from the battery itself. So how this is Maxine contributes to the thermal stability. Thank you.
Okay, thank you for the question. Now, batteries, they break out fires because of thermal runaway. And that happens, and some, they happen on an onset. So the fire delays. So after you fast charge it, and after a while, only then it bursts on fire because the reactions are already ongoing, and only when they reach a breaking point, they burst in fire. Now, Maxines, they actually facilitate this charging process. When you charge a battery, the electrons and the ions have to move in and out of the electrodes. So when this happens, this movement has resistance. So when the resistance is too much, when you charge it very quickly, input a large amount of energy flow into it, it gets hot because of the resistance. Maxine facilitates this charging process. So it smoothens this process. It reduces the resistance of charge transfer. And that is how it keeps the temperature of the battery cooler and preventing thermal runaway. It has a higher thermal stability because Maxine, because of its properties, because of the transition metals in it, and because of many other factors, because of surface termination, it smoothens out, it reduces the resistance of charge transfer. So your battery won't get as hot. When you fast charge it, it can handle more fast charging sessions, and you don't have to suffer the repercussions of fast charging your battery. Thank you.
Thank you, Mr. Jerome. I think Isha pass to you. Thank you.
All right, thank you, Jerome. Now, let us all welcome Ahmed Firdaus bin Amran from University Kebangsaan Malaysia. He is a bachelor student and he will be covering the topic of the effect of heat treatment on the microstructure and strength of graphene nanoplatelet reinforced aluminum composite.
Hi, hello everyone. Can you hear my voice?
Yes.
Okay. Wait, I will share the slide first. Can you see the slide that I'm sharing right now?
Yep.
Okay, good. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to the respected judges and the fellow audience. My name is Ahmad Firdaus bin Amran, and today I will be presenting the effect of the heat treatment on the microstructure and the strength of the graphene nanoplatelet reinforced aluminum composite, and I'm from University Kebangsaan Malaysia. So to start off, have you ever watched these movies before? So I bet that most people have watched this movie before, which is basically a Black Panther, and it's very one of the most famous Marvel characters. But I am not here today to explain the movies of the or the specific characters of these Marvel characters, but I'm very interested to share one of the interesting concept of the advanced materials that have been introduced into these movies, which is the vibranium materials. Vibranium materials in this movie is one of the materials that possess a very high strength materials, and it's very lightweight and it also flexible. Can you imagine how can a very high strength material possess a very lightweight characteristics? It sounds too good to be true, isn't it? But do we know that this material is actually exists in our real life? And the most interesting fact that we have been using these materials for a very long time and since we were kids. So can you guess what kind of product it is? So the answer is just pencils. So we have been holding the future in a trace of pencils before. Inside this pencil, there is one specific materials that have been depicted as a God's material since it exhibits very strong characteristics, thin characteristics, high thermal conductivities, wear resistance, good electrical conductivities, and transparency at the same time. And can you guess what kind of material it is? So the answer is that the material is a graphene material. So graphene is basically a layer of a carbon materials, which is basically arranged in a hexagonal lattice structure and possess a very high characteristic materials. Like I said earlier, it possesses a very high strength characteristic, high conductor characteristics, high thermal conductivity, very lightweight and very transparent at the same time. But can you imagine what actually happened when we stack this graphene on top of one another? We basically got graphene nanoplatelet, or we call it as GNP, which is basically one of the areas of focus in this presentation today. So the studies will be focusing on the composite alloy A356 reinforced GNP. So basically this alloy aluminum consists of two main elements, which is alloy aluminum A356 as a base materials and GNP, graphene nanoplatelet, as the reinforcing materials. So basically for the alloy aluminum A356 is basically a series of cast alloy with main alloying elements of silicon particles. It possesses a very high strength, high corrosion resistance, lightweight, thermal stability, and good machinabilities. Meanwhile, for the graphene, it made up of a graphene layers which is stacked up on top of one another to form a thin sheets of graphene layers. It possesses a very high strength characteristic, electrical conductivity, high tensile strength, and high hardness properties. So basically, the integration of these two materials will produce a high strength, high rigidity, high wear resistance, and thermally conductivity materials. And these materials can be widely used in various kind of automotive industries, such as aerospace, semiconductors, and also in the automotive industries. So there are a few kind of challenge that we can address within these studies. First one is that the challenge is determining the best disease treatment process to produce the composite with superior physical and mechanical properties. Despite their potential, there are still limited research and the full understanding of the full capabilities of MMCs, and this caused the challenge in the application of the composite materials in today's engineering industries. So there are two objectives in this presentation today. First one is to evaluate the microstructural changes in graphene nanoplated GNP reinforced A356 aluminum alloy. And second is we want to analyze the mechanical properties of the composite, especially the hardness of A356 reinforced GNP after undergo two types of heat treatment process, which is short T6 heat treatment and full T6 heat treatment. So let's start with something really small, the kitchen knife and the katana sword. So have we ever imagined that how can these two blades can be so hard that it can cut through all of the things? So the answer is that they have been conducted through the heat treatment process that increase their mechanical properties. So what actually is the heat treatment process? Heat treatment is a series of controlled heating and cooling cycles to alter the microstructure of the materials, thereby change their mechanical properties. There are a lot of series in heat treatment process. We've got T4 heat treatment, we've got T5, and we've got the T6 heat treatment. So basically, we are going to focus more on the T6 heat treatment for this study, which is full T6 and short T6 heat treatment. So for the T6 heat treatment, it's generally consists of three main aspects, which is solutionizing, quenching, and artificial aging. So basically, to conduct this experiment, there are four main steps, which is we are going to conduct the heat treatment process and the metallography techniques, and then we are going to conduct the microstructure analysis, and then we are going to undergo the hardness test using two types of testing. Later, we will discuss the testing methods. So the first one is that for the T6 heat treatment process, the composite materials is going to be undergo two types of T6 heat treatment, which is full T6 and short T6. For the full T6, it's going to be solutionized for 8 hours, and then we're quenching the materials composite, and then we're aging for 4 hours. So basically, it's going to take 12 hours of full cycles for the T6 heat treatment. Meanwhile, for the short T6 heat treatment, we are going to solutionize the composite for 1 hour, and then we're quenching, and then we're aging for 2 hours. So the total cycle will just take a shorter row of 3 hours of cycles. So basically, why do we really want to conduct the heat treatment process? So the main reason is that we want to conduct the heat treatment process is that we want to maximize and we want to enhance the mechanical properties of the composite materials. So this is basically the phase changes in the composite observed through the optical microscopy before the heat treatment process was conducted. As you can see here, the aluminum alloy A356 is basically the base materials of our composite. The alpha phase shows a dendritic structure, which is basically non-homogeneous. And firstly, I want to disclaimer that these phases consist of two main phases, which is the alpha phases and the beta phases. Alpha phases can be depicted as a brighter region under the optical microscopy, usually rich in aluminum phases. And the beta phases usually depict as a silicon particles, rich in silicon particles, and usually can be observed through a darker region under the microscope. So as I said earlier, phase of the alpha aluminum shows a dendritic structure, which is non-homogeneous, it's very ununiform. Meanwhile, for the silicon phase, it shows a eutectic structure with elongated little light shape, as you can see through the pictures. But after we added the aluminum alloy reinforced with GNP, after we adding the GNP, the alpha phases change shows the finer and more non-uniform dendritic structure. This basically due to the effect of the mechanical steering process during the GNP mixing process that causes the fragmentation of the dendritic arm for the alpha aluminum. But after we conducted the heat pixel forming process, we are able to observe that the process has caused the alpha aluminum to change to a more coarser and more globular form. Meanwhile, for the eutectic silicon, it doesn't show any significant kind of changes in shape. But as we can see, after we conducted the heat treatment process, which is basically short T6 heat treatment and full T6 heat treatment, we are able to observe the significant changes in the microstructural change. We are able to see that the alpha aluminum phases has shows a uniform and more coarser globular changes. Meanwhile, for the silicon phase with the eutectic structure, has changed to a more spherical form, which is before this, it's more like a needle-like shapes. So, and one of the most important things that I want to highlight is that during the heat treatment process, it's promote the precipitation of magnesium 2Si which can be considered is one of the important factor that can impede the dislocation movement within the matrix composite and at the same time enhance the mechanical properties of the composite. So here I brought to you the analysis of the macro and micro hardness of the composite materials. As you can see here for the micro hardness test using the Rockwell testing, the composite with the short heat treatments record the highest hardness value of 57.44 HRB. Meanwhile, for the 56 heat treatment, it shows a decrease in the hardness value down to the 52.28 HRB. Same goes with the viscous hardness testing. We are able to see that the composite with the short heat treatment again record the highest micro hardness value of 135.6 HV. Meanwhile, for the 46 treatment show the decrease in the micro hardness value down to the 127.3 HV. So the main difference between these two types of testing is that the macro hardness test is going to be analyzed or assessing the more structural properties of the hardness of the materials. Meanwhile, for the micro hardness testing, we are going to focus more on the specific region of hardness inside the composite materials, usually focusing on the particle of the silicon and also the magnesium 2Si. And we can also see the analysis of the density and the porosity percentage of the composite materials. We can see that the composite density with the full T6 instrument shows the highest density of 2.824 grams per centimeter cubic. Meanwhile, for the short T6 instrument, record the density of 2.8 grams per centimeter cubic. So it doesn't show a really big significant changes in the density compared to the both heat treatment. It's just around the same. Meanwhile, for the percentage of the porosity, we can see here that the full T6 treatment shows the lowest porosity percentage up to 0.071. Meanwhile, for the short T6 treatment shows the porosity percentage of 0.178%, which is not much further than one another's. And there are a few reasons or influence the effect of the heat treatment process on the hardness properties. There are three main reasons that affect the hardness properties because of the heat treatment process. The first one is that the formation of the intermetallic compound. So basically during the aging process, the intermetallic compound of magnesium 2Si will be basically formed, and the formation of this compound can be considered really important for increasing the material's hardness because it impedes the dislocation movement due to its random orientations and big size particles compared to the silicon particles. Secondly is that the globularizations of alpha aluminum and spheroidizations of the silicon particles. The silicon particle has changed from a needle-like structure to a more spherical form, and the T6 treatment has transformed the dendritic alpha aluminum structure to a more globule form. It is very important for us to basically achieve a more globule form because it's basically removed of all the sharp edges like the needle-like structure of the particle of silicons before the heat treatment was conducted that can initiate the crack propagation within the matrix of the composite. And we can see that the short T6 heat treatment possess a higher hardness properties compared to the full T6 heat treatment. This is the effect of the excessive aging, which is conducted on the secondary treatment of the heat process. So what happened actually is that the excessive aging causes the enlargement of the silicon particles and the magnesium 2Si particle size. So what's happened is that the silicon particle is basically diffused with one to another form of smaller silicon particles, forming a more bigger silicon sizes. The enlargement of this particle silicon has caused a decrement in the ability for dislocation to occur. As you can see here, the sphere size after the full T6 treatment was conducted for magnesium is bigger than the short T6 treatment. Same goes with the silicon particles. After the short T6 treatment, full T6 treatment is conducted, the silicon particles possess a higher kind of silicon particles size compared to the short T6 treatment. So why does it really matters for us to emphasize the heat treatment process and also the integration of the graphene into these composite materials? So one of the reasons is that materials is one of the foundation for the development of human civilization today, and composite can be considered as one of the rapidly developing field that remain underexplored. And by the integration of these two types of aspect, which is the heat treatment and the integration of the graphene into the composite materials can significantly increase the properties, the mechanical properties of the material itself, which can be possibly used in very high range of industries, such as in the aerospace industries, such as in the semiconductor, automotive, and oil and gas industries. So basically, let's say that we want to integrate this into the aerospace industries. We are using the heat treatment process, and then we integrate the graphene into the aerospace industries. It will able to cut off some of the weight of maybe the weight of the aeroplane itself, and at the same time it will contribute to a more fuel consumption saving toward that kind of element. So I guess the conclusion of my presentation today is that I am able to evaluate the microstructural change in the composite materials. Heat treatment will be basically allow the transformation of the dendritic microstructure of alpha aluminum to a more globular structure, and the eutectic silicon to a more spherical form. This morphology can be considered really important to enhance the mechanical properties of the materials, since it can impede the dissipation within the material itself. So we are able to the test basically shows that the short T6 treatment result in better hardness values compared to the full T6 treatment. This condition is likely due to the excessive edging, which basically reduce the material's hardness factor. However, in general, the composite, which is subjected to the heat treatment process, allow a significant increase in hardness compared before the heat treatment process was not conducted on the composite materials. I guess that's all from me. Thank you very much.
Thank you, Mr. Ahmad Firdaus from UKM. Okay, I think you have presented, how can I say, high density of information within a short period of time. Okay, that's great. You was talking about heat treatment on the composite GNP reinforced on aluminum, right?
Yes, that's correct.
Okay, that's great. So now you are working on that project.
I've been completed for that project actually because I am the degree students. Yeah.
Okay. Okay, I have question to you. Okay, maybe my colleague also going to ask you several more questions.
Okay, sure.
Okay, since what you was highlighting is on the heat treatment, okay, and you divided into two type of heat treatment, which is ST6 and FT6, right?
Yes.
So I'd like to know on the different, I mean on the grain structure, what is the difference in grain structure, okay, between ST6 and FT6, okay? The influence of the grain structure on the mechanical properties of your composite.
Okay, sure. Okay, thank you, Doctor, for the questions. So here we can see that both T6 and full T6 and short T6 treatment generally exhibit the same kind of microstructural changes. But if we look deeper, actually, for the T6 treatment, the alpha phases shows a bigger kind of micro structure grain size compared to the short T6 treatment. As you can see here, we can see that for this is one for the this one is for the silicon particles, but same goes with the alpha aluminum particles. It shows a bigger size of the grain size for the full T6 treatment. Meanwhile, for the short T6 treatment, it shows slightly smaller in size for the grain size of the alpha aluminum. Same goes with the silicon particles. Silicon particles for the full T6 treatment, it shows a bigger spheroidal grain compared to the short T6 treatment. This is because of when we heated the composite into a longer time, the alpha aluminum particles, it will allow the diffusion into a smaller alpha aluminum, and it will basically create a more bigger grain size. Same goes with the silicon particles. When we heated the silicon particles through a longer period of time, it will basically diffuse the silicon particles between the smaller one, and then it will form a much bigger silicon particles. So like for the short T6 treatment, the particle size for both alpha and silicon particles is relatively smaller compared to the full T6 treatment, as you can see through the result here for both silicon particles and also the magnesium. Same goes with the magnesium 2Si.
Thank you, Ahmad Firdaus. Okay, I'd like to invite my colleague. Please proceed with your question.
Okay, thank you very much, Mr. Firdaus.
Yes.
Just want to ask regarding very good presentation actually. I just want to know regarding to how you perform the quenching.
Oh, so basically for the quenching process, right? Okay, for the quenching process, for the full T6 treatment, so we're basically going to solutionize the composite for 8 hours at 540 degrees C. So after 8 hours, we are going to quench 1 minute into the warm water with 60 degree of the temperature, just for 1 minute. And then we are going to pull it up, and then we are going to heat it for another 4 hours at 160 degrees C. Meanwhile, for the short T6 treatment, we basically solutionize the composite for 1 hour. We are going to heat it at 450 degrees C, and then we are just going to quench in just normal water, just around 32 degrees C, the normal room temperature water. And then we are going just for 1 minute, and then we are going to age back for 2 hours at 180 degrees C.
So you're using water, right? As
yes, that's correct. We are using water.
So you just pull up from a furnace and then put it in the water quickly.
Yes, that's correct.
Then just another one question. What is the you said that the T6 heat treatment can reduce the porosity.
Yes,
can you explain the mechanism for the porosity reduction in heat
okay,
treatment?
sure. Okay, sure. So okay, so here we can see that the T6 treatment shows significant changes in the porosity and the composite materials. It's some sort of the same mechanism as before. As we induce the heat on the composite materials, the smaller grain size of the alpha aluminum will be basically kind of combined with the smaller kind of alpha aluminum and forming a more bigger kind of grain size. Same goes with the silicon particles. As we induce to the longer period of the heating process, so basically the smaller silicon particles will be combined with another smaller silicon particles and kind of forming a bigger silicon particle. So basically this enlargement of the grain size will be directly reduce the porosity within the composite materials actually.
Thank you.
Okay, welcome.
Encik Firdaus, generally you say the heat treatment causes the hardness to increase, correct?
Yes, that's correct.
So just educate me on this one. Does the higher hardness is a good thing or not a good thing? Just a simple question.
Okay, sure. Thank you, Doctor, for the questions. So in general, high hardness is a good thing, especially in the metal itself, because some of the metals usually possess a very low hardness characteristic, especially for the aluminiums. Can be considered as a soft metals compared to the steel, and it was
Okay, that brings me to the next question. Where do we use this higher? Where is the application for this higher hardness usable?
So basically, it can be usable to cast the engine block in the automotive industries because aluminium have a very high moldabilities to take form of the high castabilities to produce this kind of automotive parts, especially the engine blocks.
Okay, because that invites the next question, whether we will have greater prone to cracking. Did you investigate it from that aspect?
In terms of the propagation itself, I don't actually in depth investigate on that aspect because I'm just focusing on the hardness test itself.
Okay, thank you.
Thank you, Mr. IR Hanafi. Dr. Firdaus, do you have one to ask?
Yeah, just to elaborate a bit more on the different macro hardness increase and slight decrease on the micro hardness. Yeah.
Okay, Doctor, what's the hardness test? Okay, Doctor, for the hardness test. So for the hardness test, basically we conducted the hardness testing. Okay, as you can see here, the short disease instrument is exhibit a higher kind of hardness value compared to the full disease instrument. So this is due to the reason of the excessive edging, during the secondary process of the heat treatment, during the edging process basically. So during the edging process, the excessive edging caused the enlargement of the silicon particles and magnesium 2Si, which is basically silicon exhibit very brittle properties. Same goes with the magnesium 2Si. So basically, as we induce a more longer period of the heating process during the edging, it will basically cause the enlargement of silicons, as it's more prone to basically it's more possess more brittle kind of characteristic that kind of decrease the hardness properties compared to the short disease treatment.
Okay, thank you.
Okay, thank you. I pass to you, Isha.
All right, thank you. Thank you, Ahmed Firdaus. We will now take a 15-minute break. So I would request all the participants and our juries to please return by 11:15 a.m. for the next presentation. All right, thank you very much. All right, welcome back, everyone. Hope you've all managed to eat something during your break. So now let's continue with the presentation by Ung Weixiang from Taylor's University. He's a bachelor's student, and he will be covering the topic, the application of perlite and core as the filter media for lake water treatment. Just a reminder to our juries that the Q&A is going to be only 5 minutes due to limited time. Thank you very much. And Ang Weixiang, hope you're present and you may start sharing your slides.
Hello. So can I just quickly check if I'm audible?
Yes, you are.
All right. So yeah, okay. So just a very good morning to everyone here, and especially to the esteemed judges. I'm Ong Wei Xiang, and I'm from Taylor's University. So today I'll be talking about the application of perlite and core as filter media for lake water treatment. So let's talk about why do we even need these materials in the first place? What kind of problems are we trying to solve? So looking into the background of the problem, which is we have to focus on where the Earth's water is mostly located. Well, most of the visible water is not actually available for direct human consumption, which is in the form of salt water in this case. So only 2.5 of that is actually fresh water, defined as the water required for us to survive. So only 20.9% of that water, of that 2.5% actually, is only found in lakes, which sums up to 0.522 in total only. So we can see there's a prominent problem here. We can see that the fresh water is not readily available for most of the people, and it's actually only a small percentage of Earth's actually available water. So we can actually derive a very important problem here. Water scarcity is actually a real problem and needs to be addressed. And the methods that we are addressing it needs to be more creative and innovative more than ever. So how do we do this? We're actually looking at two different materials. So first is perlite, not to be confused with a similar name, which is with an A between. Perlite is actually amorphous volcanic gas. So cooled from the lava of volcanoes, it actually mainly consists of silicon dioxide and trace amount of other elements and other metal oxides. So this actually shows to be perlite composition. And for core, it's actually coconut husk fiber. So coconut husk fiber is basically a type of waste that we produce every year just after collecting coconuts and dispose. It's actually something that we dispose every year. So being able to repurpose this material actually enables us to create more value, and everything above that is actually just a bonus for us. So you can see that core actually has a 27% to 45% cellulose content, a 40 to 50% lignin content, hemicellulose of 0.15 to 20%, moisture of 9 to 11%, and ash. So you can see that the most significant statistic here is actually the lignin content, because it will be important later because lignin actually helps keeps its structural integrity. So moving on, we can actually ask the question of why these materials in the first place? Why these two types of materials? Let's take a deeper dive into why these two materials are actually chosen. So first, perlite. Perlite features a high porosity of 70 to 80%. So it actually provides an extensive surface area for filtration. It enables most of the water to pass through it while keeping some of the suspended solids filtered out from the water that we're trying to filter right here. And it's also a chemically inert substance, which is stable and doesn't react with most substances. So being a volcanic glass cooled from the magma of the volcanoes, it's actually quite stable and doesn't react to low temperature, small temperature changes, and it can be recycled effectively due to its stability. So lastly, it's also its good absorption capabilities. It can absorb up to 20 to 50% of its mass in water, enables effective removal of suspended solids. So how about core? is actually just a coconut husk fiber that has high, and this features high water retention capacity. It can retain water up to 8 times its weight and maintain, and at the same time maintains its moisture levels. Bear in mind, because this is quite an important feature of this core that we'll be able to use moving on. So it's also very porous at around 50 to 60% natural porosity, and is an effective filter for suspended solids. It also features a really high durability because of previously mentioned the high lignin content, and it makes it resistant to biological degradation. So how are we going to do this? You can actually see that from this diagram here, we plan to integrate plants into the solution, based not just providing a type of filter involving these two materials, but also integrating living things, like in the form of plants, to help filter this water. How does it work? So from this, I mean it quite literally, this is actually a top to bottom filtration system. So a water drips from the top and makes its way down to the bottom with gravity. And this happens through lake water input from the top. It's actually dripped from top to bottom. And this goes through a filtration, the filtration media, which consists of perlite and core. So this also enables an absorption of nutrients and any other minerals the plants may need through this process. And lastly, going through multiple layers of perlite and core, cleaner water is obtained, and the plant at the same time obtains its required nutrients. So water flows from top to bottom in this system. To help you picture it, have a clearer picture of how it works. So why this plant in the first place? So we chose the Epiprenum aurum because it's known as the money plant. It's readily available in Malaysia. You see this during Chinese New Year all the time, in the form of gifts for relatives and so on. This is a good plant choice. And why is it so? Because it has high adaptability and survivability. So this plant actually does not require a lot of water and sunshine to survive, and it actually enables this to be planted towards more indoors locations and not needing to be sustained under bright sunlight all the time. And it's also proven to be an effective water treatment agent through a study conducted in 2019. So to picture this clearer, so one of my lecturers, Dr. Lee, and her fellow companions have carried out a study on this particular system, and this is how the design will look like. So as you can see here, the water is actually pumped in from the bottom here, which is the lake water stored in the bottom. So this water is actually being pumped through a water pump, pumped all the way to the top here. And these three are actually like drippers that will drip water from the lake water from top to bottom. So the plant growing on the media, the plant will be growing on each media, and this is arranged in like a green wall-like structure. So this combined media features core and perlite in a specific ratio, which I will touch on later. And this, through this top to bottom dripping process, the lake water goes from the top to the bottom, and clean water is collected at the and this reservoir here. So you can see that this system actually enables clean water to be extracted and dirty water to be actually filtered through these layers of green wall. So it's actually an eco-friendly approach, and it focuses on using perlite core medium to treat lake water. Plants are fixed in place on this particular wall, in this particular arrangement, and this whole system relies on sufficient water retention, which these two materials actually have, for effective filtration and survivability of the plant itself. So we can see that this system has also a really interesting feature, which is the water is able to be cycled back into the reservoir, the main reservoir, to be recycled once again. So you can see this is not a linear process. This can be a circular process where water gets cleaner each time you circulate it through the perlite and core medium. So let's have a look at the experimental setup, this is actually a physical setup at my university, Taylor's University. And the lake water we use is actually from our lakeside, well-known lakeside campus. So we have a lake, and we actually get the water from the lake, and we attempt to filter it through this system. So you can see that the arrangement is quite similar to the diagram just now. Water is dripped from top all the way to the bottom, and we are actually using the money plant as our plant here. But you can notice something a little special here. You can see that the plant, the medium here is actually in a specific ratio. So more core compared to perlite in this order. So why is that so? I'll get into that later. So you might be wondering, what is the specific flow rate that makes this possible, that makes this effective? So flow rate 2, which is 28.28 liters per hour, is actually shown to be the best. So because different flow rates can cause different effects. Well, what if the plants don't absorb enough water or absorbs water too slowly? So this will cause flooding. And what if the water drains too fast? And this enables a washout of nutrients. So optimal flow rate is quite important in making sure this system actually works. So after testing, we found that the water filtration also shows some really promising results. We can see that from the TSS value, turbidity, and COD levels, we can see that flow rate 2, 28 liters per hour, actually shows pretty good results compared to the rest. And we can also see the nitrogen content removal is around 50% compared to the rest of the flow rates, which shown to be not quite effective in removing nitrogen for a very specific reason. So you can see the filter medium ratio here. We are actually testing different ratios. So a 3:1, 1:1, and 1:3 ratio for core to perlite. So from here, you can see diagrams A and B. You can see COD and turbidity levels for 3:1 are actually much higher than the rest. So it shows 3:1 to be quite effective in performing its job. Where in total nitrogen content, we can actually see that 3:1, the 1:1 takes first place. However, we have to look at the overall picture here. Just a small trade-off for COD and greater COD and turbidity removal. So overall, the filter medium chosen is 3:1 in core to perlite. And that is why you can see from the diagram just now that it's structured in this manner, where core takes most of the percentage of the medium, and lastly, perlite in just one part. So what kind of results have we obtained after carrying out some experiments on that specific module that we have, the specific experimental setup? We actually obtained different values for different flow rates, as well as the 3 main aspects that we look at. So first thing is turbidity, suspended solids, as well as chemical oxygen demand, because these 3 are very important aspects that we need to look into. For pH value, we have observed that pH value is not really affected by these perlite to core medium. So this pH value is not a big concern here. On the other hand, we can see that turbidity levels start with an average of 7.86%, and low, medium, and high flow rates have been shown to be effectively removed the turbidity from 7.86 down to a lowest of 1.15. So total suspended solids have also shown to be lower than lower than the range that the test kit is able to test from the original 41.5%. And lastly, for COD levels, we can see that it started from an average of 182.5. It has been lowered effectively through the medium and high flow rates, respectively. So we can see here that medium flow rates, combining with what we mentioned earlier, medium flow rate seems to be the best pick for this entire solution to work. So what is the significance of all this data? Seems to be a lot of numbers throwing around, but what is the significance? It's around 80% decrease in turbidity, significantly lowered TSS, to the point where it's not really measurable by the test kits anymore, shown to be negligible, and around 20% decrease in COD. This shows the solution to work, and this is a promising solution. So what is next for us in store? So first, we need to expand the green walls function, because green walls have a specific. Green walls are now seem to be for aesthetic purposes only. You can see that it's only for display, and it's not really not used to its full potential. How can we maximize this? It's by introducing this water filtration unit, enabling the green wall to be fully utilized. On top of that, we can also introduce gray water filtration, because now what we are testing is only lake water. we can research more on how we can involve the filtration of grey water as well. And lastly, you can also look into moisture sensors for self-watering. This enables the watering system to activate only when water is needed, conserving water at the same time maintaining the plant's survivability and sustainability. So in a nutshell, what we're doing is repurposing green walls and the waste we know as the coconut waste for water filtration, effectively repurposing these to original functions. So second is by improving the circularity and sustainability of the plants, enable them to survive longer, but also being able to remove impurities from the water, and you can reuse that water, filtered water, somewhere else. By reusing that water, you can also reduce costs, because building owners and people that use this product can actually enable themselves to save more water, as this water can be repurposed and be used for something else. So with these three aspects, this solution, the approach of using perlite and core is actually a very effective solution in filtering water. And with that, I end my presentation. Thank you very much. And with that, I'm open to any questions.
Thank you, Mr. Ang Wei Zin.
Yeah.
Okay, so yeah, I have question to you. But before that, let me invite my colleague. If you have any question, please proceed with yours. Thank you. Okay, maybe while waiting for my colleague to ask, I have a question to you regarding the ratio of perlite and the core.
Yes.
Okay, so I would like to know how does the ratio of the perlite to core affect the efficiency of pollutant removal, which is your three main parameters that you use, COD, TSS, and turbidity, towards the water treatment process?
All right. So yeah, very good question. Thank you for the question also. Because we can see that the filter medium ratio actually it affects the composition, right? Like how much core you're using, how much perlite you're using. So perlite and core have very different features. Core has higher water retention capabilities, while perlite has more of that filtration function. You can actually think of it that way. So yeah, what you're looking for here is a balance between retaining that water as well as filtering the total suspended solids. So when it comes to these two, you have to be you can say that a decrease in core or increase in perlite can actually greatly affect the COD turbidity levels and so on. So what's important to note is like what we have to find a perfect balance between water retention and also that filtering mechanism that we're looking for, because we want the water that we are filtering out to be clean, to be higher quality, but at the same time we want the plant to be able to absorb the water as sufficient water as well. So we need sufficient water retention as well as proper treatment of the water itself. So what you mentioned, maybe your question is regarding the ratio itself. So this ratio is more like balancing the survivability of the plant as well as the filtration of the water quality in this aspect. Yeah.
Thank you, Mr. Ng. Okay, next from my colleague, please.
Yes. One question from me. What's the quality of the water quality at the end, and also what's your target consumer on this?
All right.
Thank you.
So so as mentioned earlier, we have to look at what the lake water started off with first, how bad it was. So we can see that it has a turbidity levels of 7.86, TSS level of 4.15, and also a chemical oxygen demand on average of 1.82, which is not optimal. So from here, we're able to reduce that chemical oxygen demand slightly, actually around 20% for medium and high flow rates. However, for the turbidity levels, it has shown to be quite a significant decrease in this aspect. So we can see that this actually works. And for suspended solids as well, it's actually to the point where these water quality test kits are unable to really detect detect. It's a low enough level where total suspended solids can be seen to be negligible. So you actually see that it's very effective in terms of turbidity removal as well as total suspended solids removal itself. So you can see that that is the type of water quality that we are producing. So sorry, can you repeat your second question again?
What's your target consumer on this water or the technology side?
Right. So that's a good question, because you might be thinking, right, is this only suitable for people with lakes, or maybe only tailors can use, right? Because tailors is known for its lakeside campus. No. So we are targeting a much wider audience, because we can see that it can effectively remove lake water, and effectively remove this kind of turbidity as well as TSS from lake water itself. We can also target the main target audience will be building owners in the future. As mentioned earlier, like, more research has to be done on grey water filtration, because grey water has a lot of surfactants, which is like your soap and so on. So we need effective removal of those surfactants first before being able to introduce this into this water filtration system. So it's actually quite a direct approach. So we need to come up with something to remove the surfactants. Then the remaining water can still be applied for this water, the green wall we are using. So in short, you can say that what we're targeting at the end of the day is all building owners, especially companies that are interested in investing in a greener and more sustainable environment to work in. And this unit not serves as only a symbol of sustainability, but also a functional unit, because it actually filters water and enables the company or the building owner to reduce their water bill and additional costs due to a shortage of water.
Thank you, Mr. Ng. I think the time is up. Sorry for other judges. We should move to the next presenter. Thank you. Please, I pass to you.
Thank you, Dr. Wan. And thank you, Ang Wei Sheng. Next, we have Sarveshini Yogendran from University Putra, Malaysia. And she is a bachelor student who will be covering the topic Revolutionizing Aircraft Efficiencies, the Impact of Carbon Nanotubes on Fuel Reduction. All right. Sarveshini, are you here?
Yes, I'm here.
All right.
I can't see my slides.
I can't see yet. I think you should share your slide, please.
Okay, I'll share my. Can you all see the slide? I will make it full screen.
Yes, we can.
Okay. A very good day to everyone. I'm Sarveshini Yovindran. I am a third-year bachelor's degree student, and I'm currently doing aerospace engineering in University Putra, Malaysia. So I'm here today to present about revolutionizing aircraft efficiencies, the impact of carbon nanotubes on fuel reduction. Okay, before I'd like to start, I would like to ask, have you heard of the term carbon nanotubes? Okay, carbon nanotubes is actually a carbon tube in nanometers ranges, which means it is very small size and it is measured in nanometer diameters. Okay, as we can see in the image, the carbon are widely dispersed, uniformly dispersed, and the structure is quite rigid and it looks very compact. Okay, so today I'm going to divide my presentation into 5 segments, which is the problem statement, the objectives, the methodological approach, the findings, and lastly, the contribution to the discipline, which means the discipline that I'm currently studying, aerospace engineering. Okay, so now, as we can see, the fuel prices are going way much higher than what we are expecting. And it is actually becoming one of the main concerns of many civil airliners. So as we all know, after COVID, many civil airliners actually closed down their airline due to bankruptcy because they could not sustain in the field due to the fuel price increase. So as we can see in the graph, the fuel price is increasing with the demand of the aircraft. Okay. So the problem statement is the fuel price have increased drastically over the years. So what are the ways that are we going to take to reduce the fuel consumption or to reduce the bankruptcy of a civil airline? So in order for this, we are going to introduce nanocomposite in our aircraft application. Okay, nanocomposite is basically a composite, but in nanometer ranges. So, okay. The main objective, as I said earlier in the problem statement, our main objective is going to be the nanocomposite should be able to reduce the fuel consumption in the aircraft, as well as it should be able to improve the flight performance, which means the nanocomposite should be able to increase the flight performance when it's flying by producing lift and a few other criteria. Okay, the methodological approach. Nanocomposites are either grown on carbon fibers or are added into a polymer matrix. So as we all can see in this diagram, the carbon is actually in between the dispersed CNTs. So the CNTs are actually added in 1 or 2% of concentration of the nanotube to the polymer matrix. So they are grown in between. When nano reinforcements are added in this way, which is like dispersed, the volume is very high and it's uniformly dispersed. When the volume is high, there are few benefits that we can obtain from the carbon nanotubes, which we will see later. Okay, so the findings that we have found from the carbon nanotubes can actually produce a lot of benefits, even though it has a few cons, which I will discuss later. Okay, the first one is drag reduction. How it can actually help in drag reduction. Okay, the first is it can help to reduce the weight of the components. An example that I could give is if we have seen the statistics produced by Lufthansa, Lufthansa, they have implemented the seats, the passenger seats in aircrafts, they have replaced that aircraft with materials made up of nanoclays and carbon nanotubes. So this material can actually help to reduce the weight of the passenger seat by 11 kg per seat. So this is actually applied in aircraft A319, Airbus A319. So around the globe, there are almost 300 aircrafts, A319 aircrafts. So for one aircraft, we can actually save up to 415 kg because there are almost 300 seats plus minus 300 seats per aircraft. So for one aircraft, we can save 415 kg, which means we can save around 180,000 kg overall for all the aircraft. This is actually 4.3% of the overall fuel consumption. So the second example that I could use is, according to the research, regular paints that we use to paint the aircraft is actually around 80 kg per aircraft for a fixed wing Cessna 172 type of aircraft. But when we use the nanocomposite material, carbon nanotubes paints or nanocoatings, it is only around 113 grams, which means it reduces the fuel consumption by 2% for the overall consumption. So when the weight of the aircraft is reduced, the fuel consumption is also reduced. So the only way, one of the way that we can actually approach is the weight consumption. So the second one, second advantage that we can see from the carbon nanotube is the carbon nanotube coatings can actually get heated by the electric current. So it is very highly conductible material. So when it actually get heated by the electric current, it can melt all the ice buildup on the wings. So de-icing is a very huge process in most of the aircrafts during winter times, especially in the Europe continent, America, Canada, and Atlantic areas. So when the aircraft are flying across the globe, the ice buildups is a natural phenomena that occurs. So the de-icing is actually very expensive. It needs a lot of components in like mechanical goods and few other components in order for us to actually melt the ice buildup. But CNT, which is a very small structure, can actually help to melt the ice and can help with the weight also. The third one is CNTs are stiffer due to the larger surface area. As I said earlier, as we can see in the diagram here, it is widely dispersed and it has a very large volume and surface area. So when the surface area actually increases, the CNTs tend to be very stiff. Okay, when we are flying at a high altitude, when aircraft is flying at a high altitude, we can reduce the weight up to a point, but since it's a very high pressure area at high altitudes, we could not go very lightweight materials because the pressure can actually cause damage to the structure of the aircraft. So we need stiffer materials to help with the lightweight as well as to help the structure to sustain the pressure at the high altitudes. So we need stiffer structure, and that is why CNT is one of the best solution for choosing the lighter weight aircraft, but also the stiffer and stronger material. Composites are actually useful also, but composites are still considered heavy compared to nano composite materials. Okay, the fourth finding that we have found is it helps to promote the stealth. Okay, stealth meaning CNTs can actually help to broadcast a spectrum of light. So when there is a light, we can actually find where is the damage, where is the stresses, like the structure points that has maximum stress when the aircraft is flying. So this is why CNTs is very useful because it is easily detected by the infrared light. That is also connecting to my next finding, which is we can use CNTs to join the parts. Like we can use it to connect the wing spars and the wings. And these CNTs additives can actually help us to detect the underlying damage under the structure easily because of the infrared fluorescence. So even though it is small and it is very lightweight, since it's electrically conductible and has the infrared fluorescence, we can detect the damage easily. So this can actually help the civil airliners to detect the damage before it becomes a huge problem or cause a structural damage. So yeah, prevention is better than cure. So we can prevent it way much faster if we use CNT additives. And the last one is the seat weight, as I said earlier, one of the examples that I gave. And then, okay, the contribution to the discipline. As we all know, the usage of nanocomposites are expected to increase very rapidly. Many of us do not know the nanocomposite, or we have never heard of the word nanotechnology. It is now only increasing. But JIL's G200, it's an aircraft manufacturer company. Okay, they have been using nanocomposites since 2008, even though there was not solid evidence that it has improved the flight performance very drastically. But according to the manufacturer, they have reported that the flight performance have increased slightly, not very drastically, but slightly, even since 2008. So from there, Lockheed Martin, Boeing, Airbus, and a few other manufacturers, famous and #1 manufacturers in the world, are actually planning to implement nanocomposites in their aircraft component. Why they should use this? As I said earlier, it has so many benefits, but however, every positive thing will have a con also. So the con that we can find from manufacturing carbon nanotubes is carbon nanotubes are very hard to manufacture. It is very expensive. the structure is very hard to form because it is actually like we are dispersing the material in between the structure. So when we are dispersing the material or growing the structure inside the polymer matrix, creating like a mesh, it requires the curing process is very expensive. It takes a lot of time, takes a lot of energy, and it might become a failure also. So that is why Airbus and Boeing, they have been taking some time to do the planning and to implement it. Airbus especially, they have three types of nano implementation, which is the nano augmented, nano structured, and nano enabled. So they are implementing the nanostructures in these three different ways. So they are still thinking of implementing carbon nanotubes in it because of the hard to manufacture, but also because of its advantages. It has a lot of benefits if we think in the long term. Even though it's hard to manufacture and it's expensive, we have to see about the long-term process. If it can save so much of fuel and it can actually help with the civil airliners and all the aircrafts, then yeah, they should actually consider that into their account. And that's all from me. Thank you.
Okay, thank you. How can I pronounce your name again?
Can call me Shini, sir.
Shini.
Yes.
Okay, thanks, Shini. Okay, this time I'd like to invite my colleague to ask the question, maybe from Prof or Mr. Hanafi.
Thank you very much, Prof. Thank you, Shini, for the presentation. Shini, the carbon nanotube, the materials, the application for this material will be used as part of the aircraft, the body or the seat or what?
Actually, it can be used in different parts. Like it can be used in turbines, it can be used in wearing wing tips. Because if according to the findings, the wearing okay, I said it can actually melt the ice buildup. It is actually on the wings, so particularly on the wings. So for the drag reduction, I use the example of paint, regular paints and the nanocomposite painting, as well as the seat. So it can be used in seat as well as the aircraft frame, because we are going to paint the whole aircraft frame. So it can be used in different parts. It can even used in turbine blades, but carbon nanotubes is not specifically meant for turbines and blades. It is, I think, PU mixed with nanoclays are used for turbines and blades, and that is why I didn't include those parts inside my findings. Because I'm specifically targeting carbon nanotubes in my research. That's all.
No comment or question from me.
Okay. Yeah, still we have some time to. Okay, let me ask a question. Okay, you was talking about the carbon nanotube, right? So I'd like to know how, actually, to be specific, if you can actually explain the properties of carbon nanotube contribute to the fuel reductions of the aircraft.
Okay. Some of the mechanical properties and some of the physical properties is what actually going to help with the fuel consumption. We cannot particularly say that this is the property that is actually causing the fuel reduction in the fuel consumption. The overall structure of the whole material is going to help. As I said in the findings, it is electrically conductible, which can help to reduce the ice buildup. The ice buildup actually is like now for normal aircrafts, they are using mechanical good and so many other heavier things to reduce the ice buildup, to melt the ice buildup. So one of the properties, which is the electrically conductible property, is actually helping for that. Apart from that, the structure, the large surface area, can actually help the aircraft to have a rigid structure. So one particular property is not enough for us to reduce the fuel consumption. The overall, the structural property, the mechanical property, the other properties are what actually helping us to reduce the fuel consumption in overall. So I think so I've answered that question. Thank you, sir.
Yes, you answer well. Thank you, Shini.
Thank you,
I think
sir.
to you, Isha.
All right, thank you, Shini. Now, please welcome Yogastri Anaparampuan Chandran from University Selangor. She is a master's student covering the topic optimizing solid state of fermentation of Fusarium oxyporum for effective polyethylene terephthalate (PET) biodegradation. Yogastri, are you there?
Yeah, I'm here.
All right.
Okay, could my slide is visible?
Yeah, visible.
Okay, just a moment. Okay. Before I start my presentation, I would like to show a few picture. Okay, picture of wildlife interaction, microplastic, and toxicity chemical leaching. Okay, we have gone through those kinds of picture in our schools, college, poster, ads. Is actually show that concerns to environment poses by plastics. Okay, do we know what type of plastic is this? Okay, food containers or beverage bottles are a type of plastic called PET. PET, these are the effects of PET plastics. What is PET plastic? PET plastic is a polyethylene terephthalate plastic. It's from a polymer resin of the polyester family. As I've before mentioned, it's used for packaging and bottling. It's known for its strength, durability, and elasticity. Okay, PET consists of tetracyclic group and ethylene group, bonding by esteric bond by polycondensation. Okay, how PET was discarded, being managed till now. As we know, plastic itself posing so much concern to the environment and human health, discarding it also giving us adverse reaction. One of it is landfilling, cause leaching and greenhouse gas emission. Second, incineration, cause air pollution and open burning. Open burning is not legal, but still some individuals are still posing it. It causes severe air pollution. Okay, what if I say we could discard PET plastic without any adverse reaction? Yes, we can. Before that, I would like to introduce myself. Yogasri Anaparan Chandran. I'm doing MSc Biotechnology representing UNICEF. My supervisor, Dr. Norazna Ifes. My topic today is optimizing solid-state fermentation of Fusarium oxycorum for effective polyethylene terephthalate biodegradation. Okay, solid state fermentation. A fermentation in a solid state. It's a microbial process occurring mostly on surface of solid materials. This fermentation process in which microorganisms grow on a solid material without the presence of free liquid or less liquid. This SSF as its own rule if we want to use the solid state fermentation rules. First, it should have temperature control. Second, moisture control. Third, solid substrate. Fourth, any kind of microbe that works on it. Okay, advantages of using solid state fermentation: lower water requirement, simplicity and cost effectiveness, utilization of agriculture residue and waste products. As here I mentioned, biodegradable waste such as agriculture residue also use method from solid state fermentation, as I use non-biodegradable for plastics. Okay, as for easy understanding, I would like to explain my fermentation using a food called tempeh. It's very delicious, right? Okay, tempeh also use solid state fermentation, a fermentation that shares same principle. Okay, at the left side on my slide is a tempeh, right side on my slide is the PET fermentation that I do. Okay, firstly, we need any kind of microbes to do the work. Here on tempeh, use Rhizopus oleifera as a fermenter microbe. Here on my PET plastic is exposed to Fusarium oxyforum. Okay, next is substrate utilization. What substrate utilization? Substrate utilization is the substrate have to be utilized by the fungi to expand the growth. Here on tempeh, soya bean was working as a substrate. Therefore, the fungi utilize nutrition from the soya bean and expand the growth. In my fermentation, PET plastic serve as a carbon source for the Fusarium fungus that I use. So it utilizes the substrate to degrade the plastic. Okay, next, enzyme production. Here, enzyme production for easy understanding any kind of biological organism, whether human, fungus, any biological organism. If we consume something, we should discard it, right? As human, we defecate, we remove our unwanted toxin by urea, by waste. As same as for fungus. Fungus utilize the substrate and release enzyme as a discarded material. It's defecate. So here tempeh release proteases. Here on my fermentation, my Fusarium oxyferin fungus release an enzyme called xylanase. This xylanase works as an enzyme marker. As simple as that, if the fungi is growing means it should consume carbon. It should eat, right? As evidence of it eating, it leavings on my plastic, it should release xylanase. So xylanase work as an enzyme marker here. Okay, as I said before, this SSL as a rules of we have to conduct in temperature moisture control. So for tempeh, they decided 30 degrees Celsius will be more suitable from prevent contamination and to transform soya bean to a nutritional value add food which is tempeh. Here, similar to my project, I use fungus in incubation timing 30 degrees Celsius, as same as that. Why? Because why I choose this value of temperature? My Fusarium oxysporum fungus has a history of living in 30 degrees Celsius only. More than 30 degrees Celsius could be died, or less than 30 degrees Celsius also not suitable for my Fusarium to be actively degrade the plastic, PET plastic. Okay, this is my hero of the project. Okay, Fusarium oxyforum. Fusarium oxyforum is a soil-borne pathogen. It's live in soil. Why it's live in soil? Its role is to be wilt, boil soil, and spoil the plants. It eat the plants. It rot the plants. It rot the fruits from the plants. Okay. Okay, why I choose Fusarium as a model? I could choose any kind of virus, bacteria, right? Why I choose Fusarium oxyforum? Because Fusarium oxyforum shares same concept in degrading PET plastic. Okay, let's say plants, right? Could you experience that you pluck a piece of leaf, you can't tear it easily because it has a strong cell wall around the plant. The cell wall of the plants is constructed by complex polymer. As same as the plastic, it constructed by synthetic polymer, right? This synthetic polymer in our PET plastic is bound by ester linkage. Same as here, this cell wall is complex polymer, which is in a plant and constructed by same, bound by ester linkage. So they two same concept of molecular structure. So it works well. If the fungus can degrade well the plant cell wall means it also can degrade well the PET plastic. Next, what is the role of enzyme? As I say, xylase acts as a marker enzyme that reflect the activity of Fusarium oxyforum in utilizing carbon salts within the substrate. The presence and level of xylanase activity indicate the extent to Fusarium oxyforum is metabolizing the carbon salts. Higher xylanase activity suggests a higher level of substrate degradation as a xylanase works as a marker enzyme here. Okay, this is the visual of how fungi localize on plastic in solid state fermentation. Here on the right side of the slide, I have a flask. In the flask, I have the plastic with some inoculum. Inoculum means the stores of fungi with some nutrition for the babies, for the fungi grow a bead across a baby face of the fungi. Okay, fungi, my oxyfuran, Fusarium oxyfuran, has a structure like hyphae or thread-like structure. Easy understanding. It looks like Spider-Man's web. Spider-Man's web, like it used to grab something, right? Same as here. Here, the fungi will localize in the corner of plastic where I cut because it easily can contact with the wounded part of the plastic for easy penetration inside the PET. When fungi needs carbon salts, it penetrates using the hyphae or thread-like structure to penetrate inside the plastic and took away the carbon salts. By taking away the carbon salts from the TPA is breaking the astatic linkage holding tryptolic acid and ethylene glycol. By then, the PET monomers is break. By breaking the PET monomers, degradation occurs. Okay, these are my objectives. To compare the effect of assessed parameter, namely incubation period, inoculum size, moisture content, and incubation temperature using fusarium oxyferrum in enhancing the weight loss percentage. Evaluate xylanase enzyme as a marker in bioreacting fertility. To evaluate the psychochemical properties of PET before and after degradation via SEM, scanning electron microscope. Significance of this study is mitigating environmental impact. First, like realigning the solely relying on conventional waste management techniques like landfilling or incineration, this research can stop the loophole of plastic life cycle. The second, public health benefit. Of course, plastic causes so much public health concern, which is cause cancer. Microplastic found in food, microplastic found in breast milk. So we can safeguarding public health and well-being, potentially decrease the prevalence of plastic-related health issue in this community by doing this research. In addition to its primary goal of plastic degradation, this research exploring the use of enzymes like xylanase or fusarium oxyferrum can potentially create secondary income streams. Yes, after the fermentation occurs, there is a xylanase remain. The enzymes remain after the fermentation, right? We can use the secondary xylanase for secondary income, such as the xylanase has its own properties, which they use on pharmaceutical industries. They used to create drugs, they used to create vitamins using xylanase. So we can sell it after fermentation to create secondary income streams. Okay, these are my methods, which first I will prepare the PET plastic, second I will subculture fusarium oxyferrum, then third I will lead on solid state fermentation, fourth I will determine the weight loss of plastic waste, and then I will do a xylanase assay, how much of xylanase was excreted in my fermentation flask. Then I will go to a scanning electron microscope to see how further the fungi localize on the plastic. Okay, these are the results and discussion. Here, I've used three different size of inoculum size, which is 5 ml inoculum. Okay, here I'm repeating, inoculum means spores of fungi. 5 ml inoculum is fungi, okay? And then three types of moisture level. First is 70% liquid and 30% solid. Second is 60% liquid, 40% solid. And third is 80% liquid, 20% solid. Basically, we rely on this because my fungus is very sensitive fungus. If a bit higher moisture content also it couldn't live, or lower moisture content also it couldn't live. It should be very stable. Okay, from here, it's showing the best degradation occur on 5 ml inoculum size is on 6th week, as same as goes to enzyme activity. And it increasing 2 to 6 weeks, then it stabilizes. It shows that there's no any more fungi activity afterwards 6 because the 5 ml inoculum size of fungi was done its job. That's why here 5 ml inoculum is the best moisture level is 60% liquid and 40% solid because it goes as it spreads best by degrading the plastic. Okay, next 10 ml of inoculum size. Here it poses 4 weeks to degrade plastic. From the previous slide, it was shorten the period of degrading, right? We actually, the goal of the project is we want a very shortest period to degrade plastics. So it achieves on 10 ml inoculum, but still a very low level of percentage, right? So as same as before, it slightly increases and stops, same as enzyme activity, and stabilize after 4th week. It shows that it works fully on 4th week and no more any amendment occur in 6 or 8 or 10 weeks. As you see, what the correlation with the enzyme activity? As I said, the fungi eat something on the plastic, right? It eats carbon on the plastic, right? So it has to be replicate. So as its correlation is same, if the degradation high means xylanase activity or xylanase value, it will be high. Same goes to enzyme activity here. Okay, the best moisture control on the 10 inoculum size is 70% liquid and 30% solid. The last one is 15 ml inoculum size. Okay, this is post a very high degradation level from both inoculum size I've used, which is 5 and 10. Then it increased to 2.5% on 4th week, Same goes to absorbance of xylanate assay, which is increased until 0.45 U per gram. It indicates a very positive result. Same as that, after the fourth week, it doesn't have any activity, so it stops there. The best moisture control that works on this inoculum site is 70% liquid and 30% solid. Okay, for all the best inoculum sites, best condition is finalized on week 4, where it stops on week 4 and doesn't continue on week 6. So its work's done on week 4, and the best inoculum size is 15, and the best moisture level is 70% liquid and 30% solid. Okay, these are the SEM imaging of the plastic before fermentation is A. Looks like nothing happened, right? On B, let's take a look on B. The fungi was localized on the corner of the plastic. Third, C, after time growth, the fungi penetrate inside the plastic. It's shown clearly here. Okay, as a conclusion, all the weight loss observed in this experiment is not more than 2.5%, and the highest enzyme activity is also not more than 0.45 unit per gram. It demonstrates that the PET plastic is indeed being degraded then rather than never degraded a billion and thousands of years. And this project shows promise as an innovative approach to addressing plastic waste by using biological methods to degrade plastic in a controlled environment. Even with the modest result, this research provides a strong foundation for further optimization and improvement with a continued effort. We will be continue to amend inoculum size, incubation level period, and moisture control. We aim to enhance the degradation efficiency, leading to greater weight loss and more effective solutions for plastic pollution. Thank you.
Thank you, Ms. Yogasri. Okay, thank you for your presentation.
Okay.
Okay, I think now is a Q&A session. I like to, any one of my colleague judges, you like to ask question to Ms. Yogasri? Please proceed. Ms. Yogasri?
Yes.
Okay,
Yes,
I have one question for you. I'd like to know, because your focus is on solid state fermentation.
Yeah.
Using fusarium, right?
Yeah, fusarium.
I'd like to know what is the specific adjustment in the solid state fermentation process that is the most critical.
Okay, adjustment of
PET degradations.
Okay, so thank you for the question. Actually, sir, the difficulty of adjusting on solid state fermentation parameters is on the moisture control, moisture level. Where if I put so much of moisture control or retain so much of moisture control, let's imagine fungi as a human. If there is so much water, we could sink on it, right? So we cannot live. So as same as that, if so much of moisture control means it cannot live on the plastic and the biodegradation couldn't be happen. If a least also, it couldn't be happen. If it is least means it's a metabolic pathway of a fungus. It eats something, right? It needs water to process it to release the enzyme. So if least also, it couldn't be least. High also, it couldn't be least. So I have to choose very specifically, very minutely optimizing the liquid level and the solid level to identify the moisture control in my fermentation flask.
Okay, thank you. Maybe one more question from judges. We have about 3 minutes to go for Q&A.
Right. How about this PET? So we are hoping to address this microplastic issue. I couldn't get where, maybe I missed it, the slide. How long does it take to break down the enzyme or the fungus to break down the PET?
Okay, sir. It takes mostly on fourth week. As seen here, I have conducted 3 different level of inoculum. There's mostly recorded on fourth week. As I put the fungus on 0 weeks, right? It doesn't have anything, 0 weight loss. On second week, it have a significant weight loss where it's starting to eat the carbon source from the PET material. So it have similar but not high. But on the fourth week, it tried to expand the growth as the individual on the plant is growing, right? It needs food. So from that, it's increasing until fourth week. After fourth week, it doesn't happen anything. The suitable reason will happen on the plant is mostly depleted of its nutrition. It couldn't penetrate well on the PET because of not the structural form of the fungi hyphae, right? Couldn't penetrate well on breaking the ester. Because of the inoculum size I have put, if the more the inoculum size means, it's like I'm sending more people. If 5 ml means 5 people, 10 ml means 10 people. If 15 ml means 15 ml of man energy to perform the work. So 15 ml recorded the highest because the inoculum size is so big.
Okay, thank you.
Thank you, sir.
Thank you, Mr. Hanafi.
All right. Thank you, Yogasri. Up next, we have Kumudasri Anaparmpuan Utayarajan from University Tenaga Nasional. She is from bachelor's degree and will cover from trash to treasure, transforming black plastics to high-tech carbon nanotubes. All right, Kumudasri, are you here?
Yes, I am.
All right, great.
Thank you. Okay. Is the screen visible, may I ask?
Yes.
All right. A very good afternoon. I would like to bid to esteemed panel of judges, dear organizing committees, fellow participants, and also dear audience. Well, before I begin delving into the topic of my speech today, I would like everyone to imagine a simple scenario in your daily life even. So imagine this. You're heading on to grab your usual order of coffee, taking your usual order of lunch, eating it, and then throwing it into the trash can. Well, from all of these actions, can you realize what are you using predominantly? Well, all of them are mostly made of plastics. Everything that has been disposed of consists of plastics. And what plastics especially? It consists of black plastics. And why am I referring to black plastics? Well, I'll delve into that later. But before that, let me show you this data that have been received recently. So did you know that 8 million tons of plastic ends up in the world's ocean every year? 8 million tons is not a small value. It is not something to be proud about. And from all of that, 86% of plastics go unrecycled, and only 14% of them are recycled. And from that 14%, 15% of them consist of black plastics, and the remainder gets recycled. All right. Now, why do I keep mentioning black plastics? Like, what is so important about it? Well, it is found that black plastics actually cannot be recycled. Did you know that the near-infrared technology used by recycling facilities cannot see the color black? This is because they are unable to differentiate the color black between the belt of the conveyor in the recycling system and the color black in the plastics. Thus, all of these black plastics only ends up in the landfill, increasing our trash amounts. So how are we going to go about this? Are we just going to leave black plastics in the landfill again and again? Well, in fact, there is a solution to this. So ladies and gentlemen, I will be presenting today Converting Trash to Treasure, Transforming Black Plastics to High Technology Nanotubes. I am Kumudasri, representing University Tenaga Nasional. So this is my outline of my presentation. I will be starting with talking about introduction to carbon nanotubes, the methodology involved, the applications, limitations, and also future possibilities. So as a brief overview, what are carbon nanotubes? Well, they are carbon allotropes that consist of graphene and rolled into very cylindrical proportions. So carbon nanotubes are actually very, very small. Can you imagine a carbon nanotube being 50,000 times thinner than the diameter of your hair? Yes, but although of their small size, they are stronger than steel. Not only that, they can conduct electricity as good as copper, making them ideal for electrical components. And not only that, they are excellent heat conductors, making them very flexible to be used in various aspects. Now, there are two major types of carbon nanotubes, consisting of single-wall carbon nanotubes and multi-wall carbon nanotubes. The difference is, single-wall carbon nanotubes consist of one sheet of graphene rolled up into a cylindrical shape, whereas multi-wall carbon nanotubes consist several layers of graphene, which we call as graphite, rolled up. And in this presentation, I'll be focusing more on multi-wall carbon nanotubes. Now, you might be wondering, how are we going to change this black plastic waste into these carbon nanotubes? Well, there is a good process for this, which we call as catalytic chemical vapor deposition, CCVD for short. So based on this diagram, I shall explain briefly on the process. All right. So first of all, a two-zone horizontal liquid injector reactor, which we call as LIR, is being set up at a temperature of 780 degrees Celsius. Next, a gas mixture is prepared by using 5% of hydrogen into argon balance. After that, a catalyst solution, which is very essential, is prepared also. We use ferrocene and toluene to create this catalyst solution. Moreover, a plastic material solution is created, where this is where we use our waste materials consisting of 16.5 milligrams of plastic solutions into toluene. Next, both of these solutions are injected into the reactor, and thus we proceed with the growing process. So this catalyst will help the CNTs to grow, in which the 780 degrees Celsius will help for it to grow even bigger. And lastly, for post-growth, we would leave the carbon nanotubes to be remain at the room temperature after desired time. So based on the experiment, what can we expect? Well, a study from Swansea University has found out that even small power sources, such as this battery, is powerful enough to light up a light bulb through the CNT circuit. So this just proves that black plastic carbon nanotubes is able to conduct electricity as well. Now, also based on the study, it has been shown that by using scanning electron microscope, it is found that the average carbon nanotube diameter has not much difference using the control, white plastic, and black plastic waste. So this just proves that black plastic is just as good as any other plastic or even controlled samples. Now, carbon nanotubes are very versatile materials. It can be used in various aspects. First of all, they can be applied in energy storing devices. For example, we can be applied in batteries or supercapacitors, since they are much lighter and have high conductivity than copper. Not only that, they can be applied also in environmental sensors. So did you know that CNTs, if integrated into sensors, is able to detect toxic gases like carbon monoxide and nitrogen dioxide? Not only that, it can be used in water purification, such as membrane in water filtrations, since it has a large specific surface area and high mechanical strength. Now, this is a recent study conducted by Rice University in collaboration with Ford. So, by using the flash Joule heating process, they have found a way to recycle plastic using remainder old cars from F-150 models into CNTs. So this is also another example of using not only plastic, but also old used cars whatever plastic materials are discussed to create new CNTs. It's not necessarily waste, but any kind of materials can be used, especially if only they're using plastic. All right. However, so there are limitations consisting of from this whole process and making this material, which includes the higher production costs. So it is more expensive to produce high quality CNT, especially if they are made from waste. This ties to the purity issues. This is because creating plastic from waste materials to CNTs consists of more impurities. So there's more process and steps that has to be taken to be created pure carbon nanotubes. And besides that, there's also several toxicity concerns, which includes potential health risks involved if the gases are inhaled or improperly handled. However, I believe with proper safety measurements and precautions, and also by further research, we are able to create nanotubles in a large-scale amount, and I believe that the pros will outweigh the cons. Now, let me talk about future potentials in carbon nanotubes. So, recently, a University of Arkansas for Medical Science has conducted a research using a small rodent that has kidney cancer, and they aim to use CNT to detect the cancer cells and kill them. Yes, it is possible by using CNT and using NIR irradiation. The CNT is able to detect the tumors, and also by using heat, the help of heat, it is able to kill off the cancer cells. So our lucky rat here was managed to survive. Not only that, CNTs can be used into quantum computing as well. Well, that's a very broad range, right? They're going from biomedicine to quantum computing. Well, this is because CNTs can be used to form single electron transistors, we call it sets, where the quantum state of one electron within a CNT can form a qubit. Qubit is similar to a classical bit consisting of 0-1 binary numbers. And moreover, we can apply carbon nanotubes in flexible electronics. Why so? As I mentioned previously, carbon nanotubes have very high strength and flexibility. They are able to be molded in a lot of shapes, and thus, since conducted with its high electrical conductivity and mechanical flexibility, it is very suitable to be used in foldable smartphones and bendable screens. Now, there are plenty of environmental generosity includes in this. So first of all, we are able to reduce the amount of plastic waste that is thrown into the landfills and ocean pollutions. Not only that, we are able to increase the resources. All right, so utilizing waste materials from plastics minimize the need for us to use raw materials and conserving natural resources. Not only that, we're able to increase the energy efficiency. Well, CNT is able to increase the efficiencies of batteries and supercapacitors, which leads to longer energy storage and also higher time limit for the battery to last. Not only that, it can be used in lightweight materials as well. CNT can be used in various materials such as composite materials in vehicles like cars and buses for reducing fuel consumption and greenhouse gas radiations. Not only that, they can be used in water purification, where we use CNT as a membrane for the water filtration for water to pass through, ensuring cleaner water sources. So all of these are able to achieve several sustainable development goals, which includes responsible consumption and production, life below water, as well as industry innovation and infrastructure. Now, as a conclusion, I can conclude that from these trash black plastics, we're able to save it by recycling it in a way, chemically recycling it to multi-wall carbon nanotubes using a method called catalytic chemical vapor deposition process. And from all of this process, we're able to apply it in various aspects, including solar cells, targeting delivering anti-cancer drugs to tumor tissues, sports materials, and even energy storage device consisting of batteries, and supercapacitors. Not only that, it's able to achieve sustainable development goals and also reach for a future greener environment. Thus, I stick with this quote by Mahatma Gandhi saying, the future depends on what we do in the present. And with that, I end my speech. Thank you.
Thank you, Kumus Dasri. Miss Kumus Dasri, yeah. Okay, thank you so much for your presentation. You was talking about black plastic converting to multi-wall nanotubes, yeah. Okay, then I would like to maybe invite my colleague, maybe Prof. Sarizam. Do you have a question to Ms. Kumu Dasri? Please.
Thank you, Prof. Thank you, Doctor. Gumudasri.
Yes, Prof.
Gumudasri, am I correct? Okay.
Yes.
I just wonder that you said that the black plastic can be detected by infrared technology just because of the black color, right?
Yes.
Because of its color. So, in your opinion, why the manufacturer keep producing the black plastic?
Oh,
Since
all right.
we all know that there is a problem to
Yes.
because of the right. So, in your opinion, why?
All right, Prof. So I've read through some studies in researching why can't we just ban black plastic straight since they're so harmful for our environment, right? But it's found that it is cheaper when it comes to producing black plastics in terms of product product manufacturing. Not only that, black plastic serves a multitude of uses. We cannot just straight away ban it since it is used a lot in tires, it is used a lot in food manufacturing. So fully canceling out black plastics will only cost a loss for the economy. So that's why I believe that it is not banned, and instead of just throwing it into the landfill, chemically recycling it would be a viable option.
Okay.
I hope that answers your question, Dr.
It's okay, sir.
Thank you, Prof. Maybe Dr. Firdaus, do you have one?
Nothing from me, nothing.
Okay, we have some more time to go. Maybe from me, okay, since you are converting the black plastic, but before that, maybe I would like to invite IR Hanafi. Do you have one?
No, nothing for me.
Okay, so I want to ask you about the key challenges in converting the black plastic into multi-wall carbon nanotube. Okay, and how those challenges actually impact on the scalability of the recycling method.
All right, I shall go to this. Yeah. So what are the few limitations that we go through in this process is mainly to the production cost, because it is much more cheaper to produce normal carbon nanotubes produced by normal plastic samples instead of using waste. So I believe that if we are able to implement several solutions by further research to implement ways that we can limit the problem of high purity, we're able to solve this problem. And besides that, I believe that the next concern would be the toxicity. So the reason it is considered toxic chemicals because we're using ferrocene and toluene. These gases emit these gases are able to produce problems to human respiratory system. Thus, I think if we are able to find a way to replace these chemicals, such as using more environmental friendly options, it is able to solve the issues. Second question, can you repeat that, Doctor?
How those impact affect the, if you like to increase the scale of productions of this, how actually that this and the challenges that you highlight impact on that particular point.
I see. All right. I think from this one, manufacturing companies would be would be reluctant to accept these ideas because they'd have to change from a very big system to this new system. So if they see all these concerns, they might be quite hesitant to accept this. However, I believe that if you're able to overcome these obstacles by simple safety precautions, we're able to go through with the system more in a large scale.
Thank you, Kumudasri. Over to you, Isha. Please.
Okay, thank you, sir.
All right. Thank you, Kumudasri. So the final presentation before lunch is by Clara Ada Norman from Curtin University, Malaysia. So she is a PhD student, and her topic is utilizing fish bone meal in fish feed formulation. Clara, are you here?
Hi, hello. Can you hear me?
Hello. Yes, I hear you.
All right, great.
All right.
All right, I hope everybody sees my screen.
Yes, we can see your screen.
A food for thought for everyone. Have you ever wondered if we can use fish bone to become fish feed? The waste that is very common, discarded by humans. Fish bone has been used for natural fertilizers for plant growth. But what about for fish feed formulations? Good afternoon, everyone. I am Clara Norman. My title for today's competition is Utilizing Fishbone Meal in Fish Feed Formulations. I am representing Curtin University, Malaysia, and primarily researching at the Curtin Aquaculture Research Lab. First, we'll look into the background of my topic today, which is aquaculture. So what are the trends today in aquaculture that leads to my topic today? First, we'll see here, based on the FAO, aquaculture production is a big sector in the world where there is 214 million tons of aquaculture production produced back in 2020. And moving forward, aquatic animals and also for non-food users, one of it that contributes 81% in the aquaculture production is fish meal, which is a feed ingredient. That leads to our topic today, where we are trying to replace fish meal with fish bone meal. So, aquaculture is crucial for the global food security and the protein sources worldwide. However, in the aquaculture sector nowadays, one of the main challenges is about sustainability. So that is why sustainable aquaculture is being practiced. And one of it is fish feed production, as it remains a challenge on how do we put sustainability into fish feed production. Success and revenue of all aquaculture operations rely fully on fish feed. Therefore, it is important that we always conduct new studies to identify alternative protein sources. Of course, there are a lot of alternative protein sources that is not fish meal, but there are plant-based protein sources like soybean meal or other kind of meals like krill meal, prawn meal, shrimp meal. But fish meal still is a important ingredient that is basically used in any fish feed formulation. So what do we want to do? Our aim is to replace the fish meal that you see here into fish bone, to use with fish bone meal. So why is fish meal still a important ingredient. First, we have to know what is fish meal itself. It is a fish meal that contains high protein levels that is important for the aquaculture production. It has a balanced amino acid profile. It constitutes great digestibility and palatability for fish feed. It contains necessary fatty acids for the growth of the fish. And what is fish meal itself? It is a valorized byproduct from marine capture fisheries bycatch, and it contains all the 10 essential amino acids that is needed for fish growth. However, why do we want to replace it? Why do we not want fish meal actually? One is the main driving factor, which is cost. The cost of fish meal is expensive, and to formulate a feed, also fish meal, it is high risk due to marine pollutions. Why? One thing is that fish meal comes from fish, which is a marine capture fisheries bycatch. So whatever accumulation of toxins in the fish, when it is produced into fish meal, it will be placed into the fish feed. So the toxins stays there. Therefore, it leads to it being not sustainable at all. And if marine capture fisheries keeps on ongoing, it is continuous, gradual decline in wild fish catches eventually. Limited availability, where fish meal is still a limited ingredient. It is not that easy and not that available in the market. And there are other plant proteins that are highly available that we can use to replace this fish meal. Hence, alternative protein sources are still necessary to provide a cost-effective and sustainable diets that we can replace fish meal. So, my idea today is there we are trying to replace fish meal with fish bone. Why fish bone meal? As you can see the photo, this is fish waste, right? So we do not want the fish bone. Usually it becomes waste. So 25% of the entire production of sea capture fisheries was waste. And how is it related? Where solid waste that is discarded, it will cause a multiplication of bacteria, and it will decompose, and it will cause bad odors, therefore leading to a high biological oxygen demands. And of course, it is a threat to the water environment, not only for water environment, it is a threat towards the aquatic life also. If this fish waste is not properly managed, not properly discarded. Therefore, our main aim, obviously, is to convert this waste to a sustainable product. Leads to contribution to SDGs for 14, life below water. Why fishbone meal? Number one, it is sustainable. It is a low-cost ingredient. It has good source of nutrients. After this, we will see past research that have actually did a proximate analysis on fishbone meal. Has high levels of protein and lipid, BSE-free, high in minerals, because it is fish bone, and supports the formation of the skeleton of fishes. This is the past research that has been done on replacing fish meal with fish bone. As you can see, there's only past 4 references that I'm using here. That is how low the research has been done for fish bone meal. Of course, past research has shown that there is a increase in body weight and specific growth rate. Crude protein and crude lipid content increases, fish muscle or crude protein increases. However, some past studies also does not have any significant difference at all due to the low bioavailability of the fish. This comes back to the nutritional content of the fish bone meal. Since FBM, fish bone meal, is a rich source of minerals, can it be used to be a reliable protein source? We will be looking at the advantages and the limitations that we can get from the fish bone meal. As it is a byproduct in the fish processing industry, advantages, of course, number one is minerals. Two is in certain proteins, lipids, and small quantities of minerals that is enough and required for fish feed formulation. What are the limitations that lead to our research topic today? High levels of indigestible inorganic chemicals, where it will result in higher feed intake, reduced feed efficiency, and worse overall growth performance for the fish. And therefore, the main methodology so that we can really utilize the fishbone meal is where we need to pre-process the fishbone meal to reduce the calcium contents and improve its utilization. So, as it requires pre-processing, the direct application of fishbone meal, it will generate functionality. It is limited by its low solubility. This is due to the calcium in the bone. It's in hydroxyapatite form as calcium phosphate, which is one of the main components that is really needed for plant growth, because plant growth needs calcium. But however, for fish feed, we need the protein. So due to this component, it is hard to solubilize and it limits the bioavailability, which leads to our methods for pre-processing. And the idea here is that acid extraction is not necessary to generate the functionality and nutritional value. The main materials that we need is vinegar, which is a food grade product. Since we are looking towards a sustainable ingredient, so we'll use vinegar. The food grade product is safe to use, safe to consume. Fishbone meal here will be mixed with vinegar in different ratios, and the residue that is left on filtered papers, that is what we will use to put into the fish feed formulation later on. And the filtrates will be discarded. Methodology for the evaluation and profiling of FBM. The conditions that we need here is, of course, vinegar. We will test it on different times between 1 to 24 hours, a mixed ratio of vinegar to fishbone meal ranging from 1 to 50, same shaking speed and also same room temperature. So the residue left here, you can see, will be used, will be dried overnight in the oven, and we'll move towards to seeing the nutritional contents by doing the proximate analysis to analyze the crude protein, which is the main nutrient, crude lipid also, moisture, and ash. Since it is fishbone, therefore, ash content might be high, definitely high. So the expected outcomes is where vinegar extraction method will be able to optimize the proximate composition of FBM for better utilization of processed fishbone meal. So this is what I have done for the processed fishbone meal. How do we get the processed fishbone meal? Where we extract it with the shaker, filter, and also take out the residue that is left on the filtered papers. I have also done the proximate analysis for the fishbone meal using the Jadal method, checking on the ash, and also for the crude lipid. And to really see if this, to really determine the functionality and if it works, feeding trials are being done currently where we replace fish meal with PFBM. We make fish feed, formulate them, and also feed tilapias for a duration of 10 weeks. And we measure the growth parameters, specific growth rate, relative growth rate, survival rate, feed conversion ratio, the length and the weight gain from the first day to the end of the 10-week trial. And we will see the whole body composition, proximate analysis, and expected outcomes is where we want to see which formulation is the best of processed fishbone meal, which one will be able to replace fish meal to result in the optimum growth of juveniles This will be further on investigated. So up until today, the research outcomes for the processed fishbone meal that we want, the best ratio is 1 to 20. Proxima analysis of processed fishbone meal is where we have found between 50 to 60% of crude protein, which is enough for the average requirement of fish feed and to get good growth out of the fish later on. Crude lipid is between 8 to 10%, moisture 6 to 8, and ash is 14 to 18. So this results in an average requirements of nutrients needed for fish feed formulation. Therefore, PFBM is capable to replace fish meal, but it will be later on determined on its functionality if it really helps in the growth performance of fish after the feeding trial. Therefore, that is all for me today. I would like to acknowledge, I would like to give thanks to the committees, the industry collaborators, the funding, and my principal supervisor is Dr. Lee, and also the co-supervisors for this project. Thank you.
Thank you, Clara.
All
Thank
right.
you so much. Okay, for I think a very nice topic.
Okay.
Use fishbone for fish food, maybe in maybe I can say so.
Yes, correct.
Before I maybe ask question, I like to invite my colleague to ask a question to Clara.
Hi, Clara. Thank you for the interesting presentations.
Hi, hello. Thank you.
Have you made some economic analysis in terms of costing when you make comparison with other alternative food meals as compared to FBM? Because later on when you want to market or commercialize this, you'll be competing with the other alternative as well.
As of now, I haven't done on the economic analysis for this because I know that we will have to see on processing the fishbone meal. We can have to see on the cost needed for the process itself and the end product and before all that. So the economic analysis has not been done yet.
Okay. I mean, in terms of estimation, is it going to be at par or is it going to be somewhere higher or lower? Have you got any idea on that?
Oh, if based on my own estimation, yes, it will be lower than even using fish meal itself, because fish meal itself is a very expensive. It's an expensive product to be used for fish feed formulations. So since we are using waste towards formulating fish feed, so yes, I am estimating a low cost analysis. How to say results in the economic analysis.
All right, thank you.
Okay.
Dr. Fidaus. Okay. Other judges?
None from me.
Prof?
Doctor, just one question. Clara, Miss Clara, thank you very much for your presentation. Just want to ask one question. You have produced the product, right?
Yes.
Produce the product. So I just wonder whether the fish like your its taste or not, because there is no what you have to make sure that the fish like the meal compared to the other product.
The other ingredient, yeah. As of now, I've started the feeding trial. The fish, yes, they do consume the feed that I've given them. Yeah, so far.
So far.
Yeah.
Okay.
Also, we can see on the. May I explain further also?
Yes.
Also, it's not only entirely on the fishbone meal. It also comes back to how we formulate the feed later on, because it's not only we not only can focus on the fish meal, on the fish meal, also the other ingredients that we put inside the fish feed formulation. These things plays a role in the fish to consume the feed later on, and if it's in, if the fish wants to consume it or not. Yeah, something like that.
Okay.
Thank you, Prof. Thank you, Clara. I think
Thank you for the question.
actually I have a lot of questions to ask, but the time is really restricted here.
All right.
Maybe one day I can ask you later in separate session. Okay.
Okay, sure.
Please.
Thank you, Clara, and sorry, Dr. Wan.
All right, thank you very much.
But good news is, good news is we're going on a lunch break now, and we are going to resume our sessions from 2:15 p.m. So enjoy your meals and hope to see you back at 2:15 p.m. sharp. Thank you to all the participants so far. Hope you can enjoy your meal in a very relaxed way. All right. See you. Bye-bye. Yeah.
Thank you.
All right, it's 2:15 p.m. Welcome back, everybody. Hope you've had a great lunch break. So we will continue with our final remaining 4 presentations. So to start off, we have with us Aina Amira binti Marzuki, Elias Mahdi from University Technology, Malaysia. She is doing a PhD and her topic is Materials Then and Now, exploring the potential of magnetorheological MR foam. All right, Aina, are you there?
Yes, I'm here.
All right. Could you, just to test your microphone, could you speak louder? I can't seem to hear you.
Can you hear my voice now?
Yeah, it's a lot better.
Okay.
And I hope the judges can hear you as well. So any feedback would be appreciated. It should be okay
Yes.
if they're not okay.
Very
All right.
good.
All right.
All right. Thank you.
Off to you then.
Isha, sorry to interrupt. I think just now I see something blocking.
Sorry, you see something
Blocking the screen, like to
locking the screen?
No, it's fine. Maybe
Yes,
no, it's fine.
Okay. All right.
Thank you, Miss Isha. Ladies and gentlemen, I'm sure the word robotics is no longer new for us, especially in this world full of advanced technology. Robotics makes our life more effective and easier. It can be programmed to do the same task repeatedly with minimal error, which is something very difficult for us, right? It can be very impressive to watch them at work. But what if you take this robot out from these factories where the environment is not perfectly known and measured? To do even a simple task which doesn't require much precision, like picking up the cups as shown in this video, failure can happen. For many years, robots has been designed to emphasize strength and precision, and this translates into a very specific rigid architecture. However, using this structure, you have to perfectly measure your environment because even a small error can generate a very large fault. So now, what if I told you that we can overcome this issue by just focusing on the gripper part, the part that is circled in this image? We modify the gripper's material, make it a little soft, more flexible by just replacing current conventional material with the magic touch of our smart material. How is this possible? Stay tuned to find out. Assalamualaikum and a very good afternoon to all. My name is Aina Amira Marzuki from University Technology, Malaysia. Today, I'm excited to bring all of you for a journey on the development of our material through my presentation entitled Materials Then and Now, Exploring the Potential of Magnetorheological Foam. Here is how I'm going to proceed with this lecture. First is on the introduction. In this part, I would like to introduce you what exactly is magnetorheological foam. Next is on the background of the material, where I will be elaborating more on the material's composition, basically to address all the reason on choosing those compositions to produce this foam. After that, I would like to highlight on the fabrication process because in developing a material, the process itself holds a significant impact on the structure that leads to the desired properties. This lecture will also include a short discussion on the material's characterization, which relates back with the potential use for the gripper. I also will provide another example of potential application, and lastly, a conclusion on the overall lecture. Let's get started with the introduction. So, what is magnetorheological foam? Magnetorheological foam, which is also known as MR foam, is a type of smart material, as written in the word magnetorheological. Magneto refers to the magnet, while rheology refers to the study on the response of the material. Therefore, magnetorheology means that this material has the ability to give response upon the presence of magnetic field. As the result, the properties of this material can be continuously controlled, rapidly and reversely changed by the manipulation of external magnetic field. As you can see in my hand, this is the fabricated MR foam. It has a porous structure, giving it the advantage of being lightweight, at the same time having high flexibility and durability. Since the properties can be tuned in a real-time situation based on the applied magnetic field strength, MR foam stands out as a versatile material that is suitable for the application requiring dynamic response. Moving on to the background of material. MR foam commonly made up from two components, which are the matrix and magnetic particles. Normally, MR foam uses polyurethane as the matrix. As we know, PU foam has been widely commercialized as it is a versatile material that can be prepared in a very simple fabrication process. With only two chemicals named polyol and isocyanate, you can already fabricate a PU foam. In fact, the properties of PU foam can be adjusted based on your requirement by just regulating the ratio of these two chemicals. On the other hand, to make MR foam magnetically responsive, a type of soft magnetic particles such as carbonyl ion particles are being utilized. Soft magnetic particles are chosen for MR foam because they have the ability to rapidly respond to the magnetic field, which means when magnetic field is applied, it has fast response to magnetize. When magnetic field is removed, it demagnetizes quickly. Soft magnetic particles also have high magnetic saturation, which means they can achieve a strong magnetization even under a low magnetic field. Moving on to the next part. As mentioned earlier, to produce material, especially porous material, the fabrication process plays a significant role in producing materials with great properties. This is because it is all interrelated. Process will influence the structure, and the form structure will give influence to the final properties. Throughout the years, there has been a lot of studies on the fabrication process to produce MR foam with enhanced properties. Typically, MR foam undergoes a free-forming process. Using this process, rigid foam matrix can be produced. The properties obtained were great, but rigid matrix has higher tendency of pore deformation when force is applied to it. For this reason, a more flexible PU matrix is used. However, it requires higher concentration of magnetic particles in order to achieve similar performance as the rigid ones. Not to mention, higher concentration of magnetic particles will lead this material to become more brittle. With advancement in the fabrication, researchers try to align the magnetic particles during the fabrication by introducing magnetic field during the preparation of the foam itself. This is to ensure better magnetic particle contact for a better performance. But the drawback of this method, unfortunately, the fabrication process may become more complex and time-consuming. From this, we can observe that the key points in producing MR foam with great properties are the structure and the distribution of magnetic particles. Therefore, constraint forming has been introduced as another alternative for the fabrication of MR foam to overcome all the mentioned problems. Constraint forming process creates a restricted environment during the forming took place. So, using this method, we can control the density of the foam according to the desired needs. Okay, now we have learned about the background of material and the fabrication process of MR foam. Next, how can we analyze their properties? Is it strong enough? Is it suitable to be used as alternative material for the robotic grippers? Among various characterization processes available, there are two main characterizations that are typically carried out for MR foam. First is, of course, the morphological analysis. It can be conducted using a scanning electron microscope or even a digital optical microscope. Based on the micrograph obtained by an optical microscope as shown here, MR foam fabricated with constrained forming process, which is the micrograph on the right, has better structural properties with smaller pores as compared to the one fabricated by free-forming process as shown in the micrograph on the left. This is mainly because of the restriction created during the constrained forming process, which making the distribution of magnetic particle to become more compact per unit volume. The role of magnetic particles during the forming process is also to act as a nucleating agent. This compact distribution will trigger the nucleation process, resulting a larger number of smaller size of pores to be produced. To imagine this, let me give you a simpler situation to relate with this formation of pores. Imagine you are playing with the water bubble. If you blow it slowly and steadily, you will create a larger size of bubble, right? But when you blow it with a higher energy, like this little girl in this picture, smaller bubbles will be produced. Same situation is happening for this formation of pores. Compact distribution of magnetic particles in the constrained forming condition will contribute more energy created from the collision between the particles itself. So this will trigger the nucleation process, and therefore, smaller size of pores will be produced. The second characterization is rheological analysis. When magnetic field is applied to the MR foam, the pores tend to elongate as the result of the reaction of magnetic particles towards the magnetic field. So these changes can be analyzed using a rheometer, where it is commonly conducted under the presence of magnetic field. It is important to conduct this analysis because the behavior of MR foam varies depending on the strength of the magnetic field. From this analysis, we could observe that the higher magnetic field we apply, the higher storage modulus we could achieve. Or in other words, higher storage modulus represents that the material to become more stiffer. To relate back with our potential application just now, this dynamic behavior of MR foam allows a real-time tunable properties where if we require gentle grips, for example, to pick up an egg, like shown in the video, or like how gentle I hold this egg, you can just tune the magnetic field strength low. But if you require stronger grips, such as to pick up a tennis ball as shown in this video, or maybe to pick up a can of sardines as shown here, you can just tune the magnetic field strength higher. Interesting, right? It clearly shows that MR foam can be a promising candidate for application that requiring dynamic behavior. Apart from being part of robotic gripper, MR foam also has the potential to be used as a semi-active sound absorption material. This is due to the changes of force upon the presence of magnetic field. When sound passes through this material, the changes of force structure when magnetic field is applied will cause a shifting effect in the sound frequency. So sound can be absorbed and reduced accordingly. Therefore, what we can conclude here is that this ability to dynamically adjust its properties in a real-time situation, MR foam opens a new possibilities for innovation and provide efficiency across various industries. MR foam also might have the potential to reduce the cost of existing conventional materials such as other composite foams. Because just imagine, with a thickness of just a piece of paper, you could achieve properties as great as current material have. And with magnetorheological foam, you can even get an adjustable properties based on your needs. Thank you for your kind attention for this lecture.
Thank you, Aina Amira. Okay, thank you for very nice presentations, very clear. The point that you want to highlight, which is MR foam. Okay, Uh, I actually before I pass to my colleague to ask, I have one question, which is I did actually one of your maybe part of your presentation you did show the applications of the MRO form, and also another part of the presentation you show your model of MRO form. So what I can see both of them, the difference is the one that you show the model is fixed, is like rigid. The one that in application is like flexible. Can you explain to me what is the difference between the two?
Okay. It is because of this material is without the magnetic field. It is actually flexible, which means it can if we apply some force into it, it will return back to its original shape. And when magnetic field is applied to this material, it actually can the behavior changes.
Yes.
If we require like a stronger grips, this material will behave like a stronger sponge to carry anything that you want to pick up. So
Thank
actually,
you. Yeah, it's very clear. I thought that one is really like stiff. Okay,
Yeah.
thank you. I
you.
pass to my colleague. Please proceed with your question.
None from me.
Okay, Prof. Sarizam.
Yeah, thank you, Doctor. Ms. Aina, thank you for your presentation. In your conclusion, you said that the use of your current proposed material can reduce the cost. So in terms of what you said that it can reduce the cost
Okay.
compared to a current use material.
Okay, thank you so much for the question. How can we reduce the cost by introducing this material? So I will give you example for the sound absorption material, which is, for example, it is being utilized in an anechoic chamber. If you have heard before, the sound room. So the materials there, the commercialized material has a very like thick structure and very complex design for the use of the room. So with this material, you may have like just this thin, and the properties, the pores can be adjusted by only tuning the magnetic field strength. So by that, you can actually eliminate the shape complexity and how we want to store the material. You need professionals for that, but with MR pool, you can eliminate that. So by that, we are not assuming, but we are trying to reduce the cost from that factor. You don't have to get a complex shape, complex structure, complex settings. You just, with this material, you can have similar properties as the current available material. Thank you.
Okay, thank you.
Hello, is Dr. Wan present? He may have.
Oh, sorry. Yeah. I think
Okay.
I did ask Dr. Fidos if there is any question from him. Do you have
No
one?
question. No,
No
it's
question.
no
Okay.
question from me.
Okay, I'll pass to you, Isha. Thank you so much.
All right. Thank you so much. And thank you, Aina Amira. So next, we have the 11th presentation of the day. We are going to present Aslam Hadi bin Hamza from University Technical Malaysia, Malacca. He is a master's student and covering the topic of investigation of recycled PET based on mechanical properties through fused deposition modeling FDM process. Aslam, are you here?
Yes, I'm present.
All
Can you
right.
hear me? Alright. Okay. Alright. Okay. May I start?
Yes, please.
Yeah.
Okay. Yeah, Assalamualaikum and a very good afternoon to the honorable judges, members of the committee, and also the participants that joined us for this competition today. So I hope you guys have a good lunch break. So because I need the energy for you guys to listen to my lecture that is entitled The Investigation of Recycled PET Based on Mechanical Properties Through a Process. So this is my research. My name is Aslam Hadi bin Hamzah, currently a master student at UTEM. So before we dive in onto what is my research is about, I want to give a quick overall view of what I'm doing in my research. So in 3D printing applications, printing parameters can affect the mechanical properties of 3D printed parts. Therefore, my aim in my research is to investigate the effect of varying one-line counts on the mechanical properties of recyclable polyethylene terephthalate or recyclable plastic bottle through the use of fused deposition modeling method. So for the printing parameter will be varied through the wall line counts of 6, 18, and 30 layers. Mechanical properties and microstructure observation will be carried out. So a few results shows that the 30 layers of wall line count exhibit the highest tensile strength and the highest density in compared to the 6 and 18 layers. However, for the impact test shows that the 18 layers have much more higher impact strength compared to the other two. The microstructure observation through SEM images shows that a decrease in voids and porosity in the 30-layer wall line count compared to the other two. A simple conclusion shows that wall line count can affect or improve the mechanical properties of 3D printed parts. So a little introduction. So I want to ask you guys, what is 3D printing? What you guys know about 3D printing is a simple method of additive manufacturing. So 3D printing is considered as additive compared to the subtractive machining. Additive is to add material layer by layer to create a 3D printed part that is considered a prototype during a few years back. So there are a few types in the current market right now, a few types of 3D printing. The first one is commonly known as fused deposition modeling. It uses plastic filament to create 3D printed parts. FDM is commonly known in students or lecturers or any non-engineers that can commonly use at house or in any other offices. So it's considered pretty easy to use FDM process. So the next one use direct light printing or DLP, the additive manufacturing process. So direct light printing uses liquid resin to create 3D printed parts. UV light will trace the images to harden the liquid resin to create the 3D printed parts. And lastly is selective laser sintering or SLS. It uses plastic powder to create 3D printed parts for engineering purposes. However, the current market right now uses metal powder such as aluminium and titanium, increasing the border of sectors in medical and also automotive. So my research shows that critical concerns need to be considered, especially in printing parameters such as wall line count and also recyclable bottles that are lacking in the 3D printing area. So that's the problem statement within my research. So why do I choose one-line count? This is because many studies, recent studies, or we can say 10 years back, shows that printing parameters such as infill density, layer thickness, nozzle temperature, or printing speed can affect the mechanical properties of 3D printed parts. However, one-line count is considered lacking in recent studies, showing that one-line count could possibly affect the mechanical properties of 3D printed parts. Therefore, an investigation of one-line count is required to do so. In addition, as a few participants said that plastic bottle can affect the environment, creating plastic pollution. Therefore, by recycling this plastic bottle, we can create a new 3D printing filament that use recyclable material. So the objective of my research, the first one is to develop 3D printed sample using recyclable PET material with varying wall line count through FDM method. And number two is to evaluate the recyclable PET material through characterization, observation, and mechanical properties. So the scope of my research is that the recyclable PET will be mixed with HDPE to create a filament for FDM method. So the material will be 3D printed with varying wall line count of 6, 18, and 30 layers of wall line count. Next, we will proceed to the mechanical properties to determine its mechanical strength, and microstructure observation and also thermal analysis will be performed. So the methodology shows the workflow of the diagram of the recyclable PET. The first one is we prepare the recyclable PET and also HDPE. So we decided to blend the material 99% HDPE and 1% rPET with 3D printing of 6, 18, and 30 layers of line count. After the preparation, we develop the filament through an extrusion process to create the 3D printing filament. After the filament is successfully created, developed, we will proceed to the FDM method or FDM process with varying wall line count of 6, 18, and 30 layers. After the sample is 3D printed, we will perform the evaluation of characterization, observation, and also the mechanical properties. So as I said earlier, this shows the development of sample. First, we prepare the raw material. The HDPE is within the lab in UTM, so we can get it from the lab itself. However, for the recyclable bottle, we need to collect it to create the recyclable PET. So the collection of the bottle is through UTM in cafeteria and also offices around UTM. So after the collection, we need to cut the bottle into strips and then proceed to the crushing process to create a much more finer recyclable PET and much more uniform shape. So after the crushing process, we'll proceed to the mixing process of 99% of HDPE and 1% of rPET. After the mixing, we'll proceed to the drying process to eliminate any moisture within the material, and we can proceed to the extrusion process of creating the 3D printing filament for the FDM process. So after the 3D printing process, after the extrusion process, we will proceed to a 3D printing process. So at me right now, I have a sample that we have done for extrusion process, as you can see. So this is 99% HDPE and 1% rPET. Okay. So after the 3D printed sample, we will perform mechanical tests and microstructure observation. Mechanical test consists of tensile test, bending test, impact test, and also density test. To characterize the material, we use field emission scanning electron microscopy or FESM. And lastly, use thermal analysis, TGA analyzer, and also FTIR. So based from the recyclable PET, blended recyclable PET material, we have a few results. So as you can see right now, the bar graph shows with increasing of one line count can increase the tensile strength of 3D printed sample. So from the ISM, we just proven the tensile strength result, showing that the 30 layer of wall line count have few voids and porosity compared to figure A and B. So the fewer voids and porosity is by the 30 layer of wall line count. So as you see, the bottom picture is the 30 layer, and the top left is the 6 layer, and the top right is the 18 layers of wall line count. The density result also shows that with increasing one line count can increase the density of the 3D printed part. As you all see, the SEM images also proven with the result of the density test showing that with increasing density, it will be less voids and porosity present within the sample. However, for the impact strength shows that the 18 layers of wall line count is much more higher than the 6 and 30 layers. It is probably due to the 18 layers have much better adhesion during 3D printing process. So based on the result, as you see before, we have tried to create a product based on the material of the PET. So right now, in my hand here, this is the product that we have created. Right now, it's only we have created one. So this product is at CRL level 6 of viability demonstration. We have done a few tests for this product, and I will explain what is the product is about. So you can see on this video is on the left side is the video without the product, and the right side is video with the product. As you can see on the left side, this is the function of the product is to help us in 3D scanning process. As you can see on the left side, if you want to do 3D scanning process, we need to place these markers, as you can see. However, with the use of the product, we don't need to use the markers. We just need to use the product to create the 3D scanning process. So it will have a fast scanning process, much more easier, and save a lot of time. So from the product, we have a technology transfer with a company called 3D Gens Sdn Bhd. So 3D Gens is a company that commonly used in additive manufacturing, and classification Sdn Bhd that is commonly for molding process. So marketability of the product is through healthcare, automotive, and manufacturing throughout Malaysia. And due to why I created this product is because of rise in the 3D scanning market with demand in virtual reality and augmented reality solutions. So the conclusion that I can conclude from my research is that with varying one line count can affect and improve the mechanical properties of 3D printed parts through FDM method based on the experiment tests that have been thoroughly conducted. So this is a few achievements that I have done within my master's. So right now I'm at second semester. I have done a copyright based on the product. I also competed in a few competitions, mostly in UTM and other universities also. So I won gold medal and also a consolation award. So right now I have 2 publications that will be submitted. Number 1 on the left side is a review of method of additive manufacturing and 3D printing parameters. And another one is effect of online count on mechanical properties of FDM through 3D printed PLA parts. So that's all for me. I hope you guys understand what is my research is about. So is there any questions? Open to the floor.
Thank you, Aslam. Yes, I think we had very clear information right from you through your
Thanks.
presentation. Okay, maybe my question to you, out of several or many properties to be studied for 3D printed part, why did you actually focus on wall, what you call it, wall line
One
kit?
line count. One line
Wall
count.
line count, yeah. May I know, can you tell me the reason why you are focusing on that? Thank you.
Okay, the first reason is why I chose wall line count is probably number one is very silly, is through my internship. So I'm internship at also at Chidijans. So as I said earlier, FDM is not for prototyping in this current years. It can be used in any engineering parts, and mostly right now is being used in any other field that use FDM process. So most of the clients that came to us, yeah, if we slowly talk to them like, we want to do this and we want to do that. Okay, so we will ask, do you want your part to be more rigidity or more strength? And if the client said yes, mostly in Chidijans, they like to, okay, if they want a higher strength, we will add more layers of wall line count. So that's like a thing in my heart, like why if we want stronger, we use more wall line count. So that is why research is about. And after I doing my masters, there's a lot of research, common research more on temperature, nozzle size, infill density, infill pattern, that is mostly considered common within the research study. So that's why I chose wall line count as my research, and probably due to internship.
Okay, thank you, Mr. Aslam.
Okay.
Okay, I think next I would like to invite my colleague. Anyone? You can throw one more question to Aslam, please. IR Hanafi?
Okay, so Aslam, you're saying that the recycled PET refuse the recycled waste are better than the current material they use for the 3D printer filament?
Okay, right now we are currently experimenting. Not experimenting like we still in process of comparing with PLA. PLA is a common material that is currently being used right now. So the comparison is through the same process here. So we compare to the PLA that is bought, common PLA bought from other 3D printing companies. So the comparison is there for what I can say from my perspective and my knowledge of what I've read about the material that is mixed HDPE and rPET shows that HDPE have much more strength and much more rigidity compared to the PLA that is store-bought. So that is what I can conclude from by mixing the HDPE and recyclable PET.
Okay, thank you. That's good to know.
Thank you, Mr. Hanafi. Thank you, Aslam. I think we have a bit more. Yeah, please, Prof.
Yeah, Mr. Aslam, thank you.
Yes, sir.
Could you please show me the graph with, I'm not sure, tensile test, the tensile and
this one.
This one. So your result is saying that 30 layer is the highest one, right?
Yes.
That's right. So in your opinion, what about if we make it a 40 layer, 50 layer? So maybe the result will be higher, or what will happen? And then why you just stop at 30 layer?
Okay, from my perspective, right now the nozzle size is we're using for 3D printing is 0.4. Probably if you go lower, then the nozzle size is lower. Probably I said 0.25 or 0.2. Probably we can create it a more higher layer wall line count. But from my perspective, I guess if the layers, if increasing the layers, probably the test size tank at some point will downgrade after that due to the much more higher layers. That is my opinion on that one.
So that's mean there will be the critical I'm not sure critical ka? The optimum, the maximum.
Yes, the maximum point.
Get the
Yes.
highest tensile strength.
Yeah.
Okay.
So that's why,
Thank
as
you, Aslam.
Dr. Hanafi said before, compared to what PLA, HDPE. So that's why I will be compared with PLA.
Okay,
So
Aslam, I think the time is up. Thank you so much for your presentation. Thank you, panels.
All right.
Pass to you, Isha, please. Bye.
Thank you very much, Dr. Wan, and thank you, Aslam Hadi. Now, let's welcome Normaiza binti Nordin from University Malaysia Sabah. She's doing her master's and she will be discussing the topic Nafion membrane in microbial fuel cell properties and proton transfer mechanism. Normaiza, are you here?
Yes, I'm here.
All right. Off to you
My
then.
voice clear?
Yes.
Okay, thank you. I will share my slide now.
Please.
Okay, is my slide visible now?
Yes, I can see clearly.
Thank you for your response. Okay. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon, everyone. I hope all of you is in the pink of health today. My name is Normaiza binti Nordin. I am a master student from University of Malaysia Sabah, and I'm doing a research about microbial fuel cell for bioelectricity generation. When I started doing this research, it forced me to learn more about electricity and also the energy industry in Malaysia. And I've learned that Malaysia is still highly dependent on fossil fuel as the main source of energy. Based on a research showed that more than 80% of our source of electricity comes from fossil fuel, and only 17.2% is from renewable energy, which mainly hydropower, and less than 1% is from oil. Well, it is undeniable that fossil fuel is an excellent source of electricity. But the downside of fossil fuel is it is a non-renewable energy, which means it can get depleted over time and potentially jeopardizing our energy security if not tackled properly. Plus, it is not an environmentally friendly option since it is more, sorry. It is not an environmentally friendly option since it can produce toxic byproduct to the environment. But the good news is Malaysia is now shifting towards a low carbon energy, which means they are now focusing on other alternative fuel as well that are more environmentally friendly and are renewable. So as an effort, the Malaysia government have introduced the NETR, National Energy Transition Roadmap, with the goal of moving towards a low carbon nation. And as a groundwork towards this transition, they have also updated the energy policy. They have introduced the National Energy Policy 2022 to 2040 to reinforce and to expand the role of bioenergy technology in Malaysia energy strategy. An example of bioenergy technology is microbial fuel cell, and the increment in the amount of research on MFC signifies the relevance for us to study this technology. So for today's lecture, instead of talking about the whole part of the MFC, I'm going to narrow down the scope and only talk about one part of the system, which is the Nevian membrane in MFC. And we are going to talk about the properties and the proton transfer mechanism. So here's the learning outline. So before we talk about the Nevian membrane, I will introduce to you what is MFC, including its application, its configuration, the working principle, and where can we find the Nevian in the MFC. And then we'll continue with the Nevian membrane, its structure, properties, and mechanism. And lastly, the potential future research on membrane. Okay, to begin with, microbial fuel cell is a bioelectrochemical system that utilizes microorganisms as biocatalysts to what? To convert chemical energy into electrical energy. So MFC is almost similar with fuel cell, but the difference is MFC utilizes microorganism and also substrate as nutrient to function. Just to let you know, not all microorganisms have the ability to produce electricity. And microbes that have this ability is called as exoelectrogen. Exoelectrogen can transfer electron outside the cell to the electrode with help of a mechanism that we called as extracellular electron transfer mechanism, EET. So that is topic for another day. For substrate, it can be any organic waste. It can be wastewater, sludge, domestic or industrial waste, and biomasses. In terms of application, besides for bioelectricity production, it can also be used for wastewater treatment, heavy metal recovery, detection and bioremediation of toxic contaminant and sensors. Okay. MFC comes in various configuration. And in here, we can see two examples of the basic MFC configuration, which are the single chamber MFC and dual chamber MFC. Single chamber MFC does not have a defined anode and cathode chamber, which means the anode and cathode electrode are placed in same compartment, in a single compartment. For dual chamber MFC, they have a defined anode and cathode chamber that was separated by a proton exchange membrane. And most commonly used Nevian membrane, most commonly used proton exchange membrane is Nevian membrane due to its excellent proton conductivity. And this is the part that we are going to discuss further in today's lecture. Since you already know where we can find the Nevian membrane in the system, you must be wondering, right? Like, how do the interaction between the microbes and the substrate able to produce electricity? So, regardless of the configuration, the working principle will still be the same. But for today, I will explain the working principle by referring the dual chamber configuration. So what happened during the operation is, the oxidation and reduction reaction will take place in anode and cathode chamber respectively. In anode, the microorganism will consume the substrate and oxidize it, producing three major products, which is the carbon dioxide, proton, and also electron. The electron first transferred from the bacterial cell to the electrode with help of the EET mechanism, and then it will continue its journey to the cathode electrode through external wire. So the movement of electron was driven by the difference in electrical potential. Proton, on the other hand, will also move from anode to cathode, but by passing through the Nevian membrane. So the role of Nevian membrane here is to separate the anode and cathode chamber that usually have different condition, and to facilitate the proton transfer activity, and to block any anionic species and huge molecules from entering the anode chamber. That is the oxidation in anode. Now let us see the reduction reaction in cathode. In cathode, the oxygen that are present in cathode chamber will pull the electron and proton react to it to produce water. So the overall redox reaction from the production of proton and electron until the transfer of electron and proton from anode to cathode consequently produce electricity. So the overall performance of the MFC can be affected by several factors. And one of the factors is the efficiency of the proton transfer. Efficiency of proton transfer. So to understand more about the properties and the proton transfer mechanism of Nephron membrane, we have to look into the structure of the membrane. So Nephron membrane is a sulfonated tetrafluoroethylene copolymer that consists of hydrophobic fluorocarbon backbone and also hydrophilic sulfonate group. So this structure responsible in determining the properties of the membrane. So due to the presence of this unique hydrophilic and hydrophobic structure, the membrane selectively permits certain ions such as proton to pass through the membrane while blocking huge molecules and also anion species from entering the cathode and reacting to the entering the anode and reacting to the anode electrode. Okay, that is the first property. Secondly, we can see here that Nephron membrane have the sulfonate group. So this sulfonate groups is the one that facilitate the high ion exchange capacity. And since it is hydrophilic, so the performance of the membrane highly dependent on the hydration level. Okay, and the proton transfer was also facilitated by the hydrophilic sulfonate groups through two key mechanisms, which are vehicle mechanism and Grott's mechanism. But for today's lecture, I'm going to explain on the Grott's mechanism only, since it is more likely to occur in MFC with aqueous substrate. Now, let us see how the Grott's mechanism facilitate the proton transfer from anode to cathode. We can see here is the sulfonate groups. When the sulfonate group here get in contact with water molecules, they will form a hydration layer. And within this hydration layer, there is a formation and also breaking of hydrogen bond. And this can occur when the proton encounter the sulfonate groups, forming a temporary hydrogen bond. So this proton will move from one sulfonate group to another sulfonate group by forming a temporary hydrogen bond with nearby water molecule. So this proton will hop from one sulfonate group to water molecules back to sulfonate group and until it reach the cathode chamber. Okay, and the efficiency of this proton transfer activity can be affected by several factors, including hydration level, membrane thickness, pH level, contaminant and impurities, temperature, ion exchange capacity, mechanical stability and durability, and biofouling. So we take one example here. For temperature and hydration level, these two factors can be interrelated with each other. So as the temperature increase, the vibrational motion of both the polymer matrix and the water molecules in Nephron membrane also increases. So this enhanced motion facilitates the formation of interconnected water network, which are essential for the hydration level. So that's mean as temperature increase, hydration level will also increase, resulting in increment in enhancement in efficiency of proton transfer. So efficient proton transfer can reduce the internal resistance of the MFC, which enable the voltage to be maximized, reduces the overpotential, and maintain stable operation. Okay, so the reason why I decided to talk about Nephron membrane today is because even though the research on MFC is increasing, it started to slow down due to high cost and recycling issue of the common membrane. So understanding the ability and limitation of the Nepean membrane will be helpful for us in developing alternative membrane with comparable performance. So Nepean membrane has an excellent proton conductivity due to the presence of hydrophilic and hydrophobic domain. However, it is expensive and sensitive to falling, which over time causes low energy recovery and needed replacement. So one of the way to overcome this issue is by discovering other alternatives for Nepean membrane. For example, by using an earthen membrane that was made from the mixture of clay, bentonite, fly ash, sodium carbonate, sodium metasilicate, and boric acid. So this is a study that have been reported by Pranab Jyoti Sarma et al. 2023, and based on the comparison between earthen membrane and also the Nepean membrane, we can see that the earthen membrane, in terms of the proton conductivity, it's able to outperform the Nepean membrane. And in terms of cost, the earthen membrane fabrication only required 1,279 rupees per square feet, which is around RM73 ringgit Malaysia per square feet, compared to 80,580 rupees per square feet, which is around 4,000 ringgit Malaysia per square feet for Nepean membrane. So this study also reported that the earthen membrane can last for over 6 months. But since the cost of making the earthen membrane is cheaper, the problem can still be solved by replacing it after use. So for future research, we can explore other alternative material to replace the Nepean membrane, such as inorganic membranes, for example, silica-based membrane and ceramic-based membrane. We can also use natural and biodegradable formula, for example, chitosan-based membrane and cellulose-based membrane. Okay, as a conclusion, MFC is a promising alternative energy source. They not only able to produce clean energy, but they can also be used to treat waste and contaminants. So, however, the development of this technology has slowed down due to the cost and recycling issue associated with the membrane. So this highlight the need for us to understand the advantages and disadvantages of the Nepean membrane to develop alternative solution that address these challenges while improving the alternative membrane as well. So I think that's all from me. Thank you.
Okay, thank you, Normaiza. Thank you for the presentation. Okay, I'd like to invite judges to ask question to Normaiza. Dr. Fidos?
Yes.
Okay,
I have one question. With regards, thank you, Normaiza. Interesting presentations. With regard to the membranes, the performance is related to the amount of surface area available, right? So how thin is your Nepean membrane is expected to be fabricated? Because you need to go through complex geometry in the PM later on also.
So sorry, the question is?
How thick is the membrane that you expect when you produce later for membrane? It's going to be the same as a earthen membrane as well?
So wait, I open the slide first. Based on this study, the thickness of the Nepean membrane they use is 0.16 mn. Meanwhile, for the earthen membrane is 6 6 mm, which is thicker compared to the Nephron membrane. So in terms of thickness, um, um, we can compare the proton mass transfer to see the effect of thickness on the performance of proton transfer. Okay, and the proton mass transfer for Nephron membrane in this study is actually higher compared to the proton mass transfer in of the earthen membrane. So but the one that determine the efficiency of the conductivity of the proton transfer is the proton diffusion coefficient. So maybe if we want to further improve the performance of the earthen membrane, we can try to reduce the thickness of 6 mm to lower than that. Because even using the 6 mm, the proton diffusion coefficient of earthen membrane is still show better performance. So I think for earthen membrane, we just need to reduce it lower than 6 mm, if possible.
Okay, thank you.
Thank you, Doctor. I think IR Hanafi, maybe this subject interests you. Do you have any question to ask?
Yes, it is interesting, but so far I have no question for her yet.
No problem. Prof. Sharizam?
Same to me. There is no question from me.
Okay, then maybe from me one last question. Yeah, you was talking about mechanism just now. Can you hear me?
Yeah.
Okay. Mechanism. Yeah, I'd like to know if you can a bit more talk about the mechanism in Nephron membranes that the effect the transfer efficiency of the proton.
Okay. The question is?
So the question is, can you explain the mechanism of, I think you did mention about Grotus.
Yes, Grotus mechanism.
Yes. Can you explain about that a bit more?
You want me to explain again?
And not again, but maybe simplified version.
Oh, okay. So for Grotus mechanism, it is also known as proton hopping, if I'm not mistaken, because the proton hop from the movement of proton moving from one sulfonate group to another sulfonate group is by depending on the water molecules. So the proton will hop from the sulfonate group to water molecule, and then it will hop again to sulfonate group until it reach the cathode chamber, like that. It's different. It's different when we compare with vehicle mechanism. Vehicle mechanism need a vehicle ion to for the transport of proton, not necessarily needed water lah. Like that.
Thank you, Nomaiza. Thank you. Okay, Isha, I pass to you.
All right, thank you, Normaiza. Our final presentation now is by Natasha Salsabila from University Tun Hussein on Malaysia. She is a master's student and she will talk about the effect of amine and thiol as functional groups on gold nanobiopyramids properties for glucose sensing. Natasha, are you there?
Yes, I'm here. Can you hear my voice?
I hear you.
Yes,
I
can hear yours.
I will present my slide now. Wait a moment. Okay, I think it's visible now, right?
Yes.
Okay. Now, are you familiar with this or even this? I'm sure that all of us, all of the participants here, like to consume them. And I personally admit that I like them because they are very delicious and convenient. You can get them anytime and anywhere. If you see, people nowadays even prefer to consume them rather than mineral water and lack of exercise. So this simple thing can give us a brief understanding of why diabetes is very popular and still become an issue for the next few years. Diabetes is very scary. It can cause so many deaths, with only 60% had a proper diagnosis. This condition will worsen until at least 2045. Hence, the need for glucose sensing method has gained much attention and improvement over the years. The existing method are glucose meter and urine testing. Can you imagine how many diabetic patients must feel pain and uncomfortable when checking their blood glucose level through glucose meter? Or if you prefer to do urine testing, you should wait for a long time to get a result. So, this is where plasmonic sensor come from. The sensor can be performed in non-invasive way, fast detection, and can be performed by everyone without an expert needed. However, the challenge is to do glucose sensing using plasmonic sensor need to be improved in the selectivity and stability aspect. So, how can we develop a plasmonic sensor with dose of advantage with improved selectivity and stability aspect as well? Okay, one of way to achieve that is through sensing material modification. So here I am. I'm Natasha, and today's lecture will discuss about the modification of gold nanobipyramids using amine and thiol groups as sensing material for glucose sensing application. Basically, there are a lot of materials on this earth, both in a bulk size and in the nanoscale. The nanoscale material, well known as nanoparticle. For your information, nanoparticle itself has increased surface area that is very suitable for sensing application. But why did we focus on metal nanoparticle? So, besides high surface area, metal nanoparticles are very reactive to the living cell, and it's very promising feature to be applied in the biosensing field. And it can be used to detect very low of concentration of targeted analyte. There are a lot of type of metal nanoparticles, but gold become the popular one because it's very easy to modify with other molecules, so it can be used to detect various things. And then we came up to the next question. What type of gold nanoparticle that can be used? Well, gold nanoparticle with bipyramid shape is chosen because it has a higher sensitivity than other form and the facile functionalization process with other functional groups, so it can be used to detect certain molecules. In this case, we want to use gold nanobipyramids or GNBPS for glucose sensing application. So the functional group used are amine and thiol because they can construct a strong chemical bond with glucose molecule on the gold nanobipyramids or GNBPS surface. Then, how can we synthesize or fabricate the gold nanobipyramids? So the most popular method to synthesize gold nanobipyramids is through seed-mediated growth method, or SMGM, which divided into seeding and growth process. In seeding, we focus to produce gold nanoparticle as a seed. Then, the seed will grow into the bipyramid structure or shape in the growth step. After that, we functionalize gold nanobipyramids using amine and thiol groups for 0.5 until 72 hours to modify the surface. So gold nanobipyramids or GNBPS can properly bind with glucose molecule. The interaction between amine and glucose molecule is known as imine bond, while thiol and glucose molecule is known as disulfide bond. Okay, we already know how to synthesize and functionalize gold nanobipyramids, and here is the result solution. So in the synthesis, there is a mechanism of growth from seed. So an increasing time leads to the decrease in the gold source, which affect to the production of truncated and gold nanobipyramids or GNBPS cannot grow in the perfect shape. Then, figure 2 shows a GNBPS or amine functionalized GNBPS for 0.5 until 72 hours. If we see here, after 12 hours, the solution turned light yellow. Figure 3 shows T-GMBPS or tile functionalized GMBPS for 0.5 until 72 hours. We can see here that over 12 hours, the solution turned darker. And this is the characterization result of pure GMBPS using UV-Vis, XRD, and then VSEM. Next, we have TM, zeta potential, and the last one is FTIR to confirm that gold nanobipyramids have been successfully synthesized. Next, we move on to the AGMBPS. So this is the UV-Vis spectrum of AGMBPS or amine functionalized GMBPS. Based on this result, generally, the absorbance spectrum shifted into the red region, indicates an increasing in the aspect ratio. So for your information, aspect ratio itself is the ratio between length and width of gold nanobipyramids. And the highest absorbance value is obtained at 3 hours. If we see here, over 12 hours, there is no peak anymore in the absorbance spectrum, indicates that there is no nanoparticle remaining in our solution as a side effect of over-functionalization using amine groups. Next, XRD. So this is the XRD pattern of AGMBPS. If we see here, there is an additional peak, which consists of amine molecules such as Si, N, H, and O. And the highest additional peak is obtained at 3 hours. Indicates that the highest binding reaction between amine groups and the surface of gold nanobipyramids is obtained at 3 hours. Next, VSEM. So this is the VSEM result of AGMBPS. The highest surface density is obtained at 3 hours with value of over 59%. Next, we have TM here. So based on this result, the tip and slope angle of AGMBPS is 1.01 times higher than pure GMBPS, indicates an initiation of surface scraping phenomenon, which conducted by amine groups will lead to the morphological change. And then we get the zeta potential value measured at 2.5 millivolts, which is increased from pure GMBPS. And the last one, we have FTIR. So the utilization of amine groups can influence for the wave number shift. Next, we move on to the TGMBPS. So this is the UV-Vis spectrum of TGMBPS or tile functionalized GMBPS. Based on this result, generally the spectrum shifted into the blue region indicates a decrease in the aspect ratio, which is a bit different from AGMBPS before. And the highest absorbance value is obtained at 3 hours. If we see here, the spectrum over 12 hours turn broader indicates that the shape of nanoparticle is not typically bipyramid. Next, XRD. So we also have XRD pattern of TGMBPS. So if we see here, there is no additional peak as AGMBPS before, indicates the purity of nanoparticle itself. But if we clearly see the influence of tile groups to modify the surface of gold nanobipyramids can increase the 111 and 200 plan. Next, we also have VSEM here. So based on this result, the highest surface density is obtained at 3 hours as well, with value of 75%. Next, we also have TM. So based on this result, there is no surface scraping phenomenon or morphological change here as AGMBPS before, with zeta potential value measured at minus 0.5 millivolts, which is decreased from pure GMBPS. And the last one, from FTIR, we obtained that the usage of tile groups to functionalize the surface of gold nanobipyramids can influence for the wave number shift as well, similar to AGMBPS. Okay, we already know how to synthesize and functionalize gold nanobipyramids, and we already know about the properties change after the functionalization process, and here is the proposed mechanism of functionalization process itself. So based on the characterization result, we get that amine groups can influence for the morphological change, while tile groups can allow for the nanoparticle agglomeration. So this phenomenon also corresponds with the general understanding of zeta potential value, where positive charge of amine influence for the nanoparticle agglomeration inhibition, and vice versa for negative charge of thiol. Okay, ladies and gentlemen, we already know how to modify the surface of gold nanobipyramid so it can be used to detect glucose molecule in the properly way now. And then we came up to the next stage. How can we develop a plasmonic sensor? So here is the setup, which consists of light source, fiber optic, chamber, spectrometer, and the last one, computer, and equipped with a software analyzer. So, gold nanobipyramids as sensing material and glucose as targeted analyte will be placed in the transparent cuvette with ratio 5:1 and then put in the chamber. Light from the light source will be exposed to this chamber through the fiber optic. So when gold nanobipyramids detect glucose, it can cause a spectrum shift towards the localized surface plasmon resonance or LSPR spectrum. Then the spectrum will be recorded by the spectrometer and the last one visualized using computer software. So for your information, localized surface plasmon resonance is the optical phenomenon conducted by metal nanoparticles when they are irradiated with light in a specific wavelength, and it's very sensitive to the surrounding medium change. Okay, now the moment of truth. So we test pure GMBPS. Next, AGMBPS, and the last one is TGMBPS for plasmonic response mechanism. So based on this testing, we confirm that pure GMBPS and AGMBPS, and the last one is TGMBPS, can be used to detect different medium denoted by intensity change and wavelength shift. Then we, of course, want to know about what is the optimum time to functionalize or to modify the surface of gold nanobipyramid so we can get the best signal response for our plasmonic sensor application. So based on this result, 3 hours of AGMBPS and TGMBPS has the strongest signal response denoted by the highest intensity value. So this result also corresponds with our previous characterization result, where 3 hours has the highest absorbance value and also has the highest surface density value. Okay, next we of course test into the selectivity aspect using pure GMBPS, AGMBPS, and the last one is TGMBPS. And if we see here, AGMBPS and TGMBPS basically perform a better selectivity response than pure GMBPS, with AGMBPS has the best selectivity response than other. Next, we also test about the stability aspect of pure GMBPS, AGMBPS, and the last one is TGMBPS. If we see here, actually AGMBPS and TGMBPS also perform a better stability response than pure GMBPS, denoted by a lower error value, with TGMBPS has the best stability response than pure GMBPS and AGMBPS. Okay, now I will summarize the whole discussion. So overall, gold nanobipyramids, or GNBPS, have been successfully synthesized using seed-mediated growth methods and functionalized using amine and thiol groups, where amine influence for the morphological change, while thiol allows for the nanoparticle agglomeration. And then based on the characterization result and also based on the plasmonic response mechanism testing, we obtained that 3 hours is the optimum time to functionalize and to modify the surface of gold nanobipyramid so it can be used to detect glucose in our plasmonic sensor. And then when we test about the selectivity and stability performance, it is proven that amine and thiol groups can improve the selectivity and stability aspect of our sensing material. And here is the proposed recommendation based on this our research stat. And that's all from me. Thank you for your attention.
Thank you, Natasha. Okay, for very, I would say, excellent presentation. Okay, I'd like to invite my friend, judges, Prof. Sarizam.
Thank you, Doctor. There is no from me.
Yeah, okay, thank you. IR Hanafi.
I don't have any question.
Okay, how about Dr. Firdaus from Petronas?
Nothing for me as well. Thank you.
Oh, okay. So now left only me. I have to ask, okay? So yeah, you was talking. Yeah, actually I was wondering, you really focus on, I mean, the goal by pyramids. You did mention about that, right?
Yeah,
So
gold nano by pyramid.
why I mean that by pyramid is so important in your study?
Okay, thank you for your question. So in the plasmonic sensor application, the important parameter is about how we can choose the material that is very reactive to the light. Because when we use plasmonic sensor, we should make sure about the light interaction matter between nanoparticle and between the sensor. So why we choose gold nanopyramids? If we see here, gold nanopyramid has a sharp tip. This tip can enhance the electrical enhancement field. This kind of parameter can increase the refractive index sensitivity and figure of merit value. These two type of parameter is very crucial for the sensing application, especially using plasmonic sensor. So this is why we choose gold nanopyramids. Before we found about the gold nanopyramids, recently researchers using gold nanorod. So gold nanorod also have similar properties along with the gold nanopyramid, but gold nanorod is not having sharp tip. So their refractive index sensitivity and figure of merit value is not that higher than gold nanopyramid. So when we want to do plasmonic sensor, it is recommended to use gold nanopyramids. But when we talk about another sensor like electrochemical, for example, or mass spectroscopy, we should do further analyze. How about the best material sensing decided? That's all from me.
Okay, thank you, Natasha. And to get the shape, is it by random or by controllable parameters?
Okay, to get this sharp tip, we can control by using type of material. So in our method, we use three type of material. First, we use gold precursor. Gold precursor act as our gold source. And the second one is reducing agent. We use reducing agents such as NaBS4, platinic acid, and silver nitrate. These three type of material can shape the tip. So this type of material can make our shape into the bipyramid. And the last one, the type of material that we use is about surfactant, act as the stabilizer agent. The stabilizer agent we use here is CTAP.
Understood. I think that's all. Thank you, Natasha.
Thank
Okay,
you.
it's very clear. What a response from you. Thank you so much. I pass to Isha, please. Thank you.
Thank you, Dr. Wan. Thank you, Natasha, and thank you to all the judges and participants who have been there with us. This was the end of the presentations, and I'm sure you're all excited and looking forward to the results. However, we need to give our judges enough time to come up with the best presenter. So they will now deliberate on today's presentations. Please stay tuned for the announcements of the finalists, and we will circle back at 4:15 p.m. And announce the winners. So hope to see you soon in a few minutes at 4:15 p.m. That is when the judges will have finalized the results. So stay tuned. Good afternoon, ladies and gentlemen. We will be announcing the results at 4:30 instead of 4:15 due to some unforeseeable circumstances. Please be patient for a few minutes longer as we will be announcing the winners in roughly 13 minutes. Thank you so much. Ladies and gentlemen, thank you all for waiting. We have now arrived at the moment we've all been waiting for. I would like to invite Dr. Mohammed Khairi Faiz to announce the finalists for the National MLC 2024 semifinals. Let's welcome
Right, okay. Okay, sorry for the interruption. Okay, thank you very much, Isha. All right, okay. First of all, we would like to thanks all participants, okay, to join these competitions. Everyone has showed their tremendous efforts and hard work, okay, through for these competitions, okay. But of course, this is competition. We have the winners, and so we have to choose, okay, 5 finalists, okay, for the final round, which will be conducted on 24th of September. Next 3 weeks, yeah. So the judges have made quite a tough decisions, okay, and I would like to thanks all the judges for their fairness, okay, during the judgment sessions, okay, and here is the moment that we are waiting for, okay. I will announce the winners, the top 5 finalists in the alphabetical order, okay. All right, the first winner is Aina Amira binti Marzuki Lais Mahadi from University Technology Malaysia. Congratulations. The next winner is Aslam Hadi bin Hamzah from University Technical Malaysia, Melaka. The third winner is Jerome Liu from University Malaya. The fourth winner is Normaiza binti Nordin from University Malaysia, Sabah. And last but not least, our top 5 finalists is Natasha Salsabila from University Tun Hussein on Malaysia. Once again, congratulations to all participants, and of course to other participants who did not to the final round. I also congratulate for your hard work, okay? And we may see again next year, hopefully, to get the top 5 finalists in the next round, right? Next year session. Thank you very much. I pass it back to Isha.
Thank you, Dr. Khairi Faiz. So can we have the top 5 finalists turn on their cameras so we can take a group photo before we end the session? Are the top 5 finalists present?
Yes, we are still here.
Okay, they are. I see. Okay, yeah. They're all there. All right. 1, 2, 3. Cheese. Okay. One more time. 1, 2, 3. Okay. Thank you very much. So congratulations to all the finalists, and thank you to everyone who participated today. We hope the audience got to learn from these presentations just like we have. And thank you to the juries and chairpersons of IMM for taking their precious time out of the week to be here with us today. To everyone else attending, if this has left you wanting more, don't sweat because we have the finals in just 3 weeks. We wish the finalists the best of luck in the upcoming final round. And with this, we conclude the semi-finals of the National Materials Lecture Competition 2024. Have a great day ahead and see you once again in the finals.
Thank you, everyone, and bye.
Thank you.
Thank you all.
Okay.
Okay, right. Okay. Dr. Hakim, anything would like to say?
Yeah, don't say so many times. You sound like Hasli.
So a big thank, to,
right.
And I want to say this, okay?
thank to the Center of Advanced Material, right, for hosting these finals. Okay.
Thank you.
Okay, so I would like to thank to Center of Advanced Material, of UC Malaya, right, for hosting this time semifinals. So gratefully there's this event runs smoothly today. Okay, and we wait up for the final round. Okay, final
Okay.
round. And thank you very much to the Faiz and your team. Okay. Okay.
Thank you very much, Hakim, for your assistance as well. There's a lot of technical issues today too as well.
Yeah. Sorry lah jika ada some delay from my side, right?
No, it's okay. We are learning as well, so moving forward to the next round, the final round. Okay, thank you, Dr. Hakim. So anything I will just update through the WhatsApp right there for the final round. Okay, thank you.
Okay. Thank you very much, Mr. Faiz and your team. Okay, thank you.